All right, if we can bring it in, have a seat, we're going to get started here in a minute. Hey, we're good. All right. Well, welcome everybody to EPF Day 6 here in Buenos Aires, in the Usina co-working space. Happy to have you all here at the culmination of another great protocol fellowship cohort. Yeah, give yourselves a round of applause for being here. This is a pretty monumental undertaking that you guys have done, and love that you're here.
Yeah, welcome everyone. Thank you so much for making it through the 5 tedious months of research and development, and then taking like 20-hour flights or more for some people all the way to the end of the world here almost, right? So it's great that we can finally meet in person with many of you. It's for the first time. So yeah, thank you so much for being here. And yeah, welcome to EPF Day. It's our own day to appreciate each other's work, to enjoy each other's company. So please pay attention to your fellows and also maybe learn from their very final update after the weekly stand-ups and everything that we did. We will have the culmination here with the presentations and also a quick panel, or small panel, which will be sort of like the last office hours as well. So yeah. You already saw this before, so I'm just gonna do it quickly, but some statistics, because the cohort 6 was, I believe, very successful. We had many great fellows, even more of them coming now. Welcome, guys. So in the cohort 6, we started in June, and 43 people used the updates. 43 people actually submitted that they intended to do something. 33 of them actually did something. Most of them are here today, so again, welcome and appreciate that you, those of you who managed to really pull through and make it all the way till today and actually deliver something. You guys delivered 31 different projects, most of them successfully culminating into PRs. We had so many, I didn't count that, but we had so many people submitting PRs to the clients, to the different projects, libraries, building their own separate projects. So it's been quite a lot of work that has been done, and it's been reported in 500 updates, or around 500 with dev updates. So the final reports, it's even more than 500. I read all of them, mostly tried to read all of them actually. Sometimes I'll be honest, sometimes I skim through them because like it's when I wake up on Monday morning and there is 20 PRs, I just need to do it kind of fast. But I appreciate each of yours updates. I want you to know that you don't submit them just to the air, but people are actually reading it. At least one person is reading it, and really appreciate your work, your report. So after all of this, after 20 office hours calls, 21 stand-ups, we are finally here in the final EPF day. Actually, there are 2 EPF days now that I think about it. I put the one EPF day, but we had one in Cannes. This is the real one. Yeah, this is the real deal because we have a really nice setup here with proper venue, not the tiny cafe in Cannes where we barely fit, but a proper stream. So everything that we do today is live stream. Be nervous because we are on the internet. Everybody will see it. Again, please share it for those who came. We have it live. So if you want to share it with your mentor who couldn't make it, or with your family, we have the link in the chat. You can use or share it on Twitter for people to see your work before you present. And just again, just a quick advice for you. I saw so many of you submitting the final reports, and it's been during DevConnect, so I'll be honest, I haven't read those that are opened in PRs as of yet, but thank you so much for making them. If you have not submitted the final report, it's past deadline, so please do it tomorrow or so. Do it as soon as possible, so we have the final data from the cohort. Again, yeah, share your presentation live. That's what I just said. We have this day for ourselves. There are a couple of mentors who made it here. I also welcome the people from the client teams, the mentors who took the long way all the way to the co-working here to join us. But for those who are looking for other connections, new mentors, other opportunities, please use the DevConnect, use this week in Buenos Aires to network, to meet people. So there are a couple of people here, but in the main co-working, in the DevConnect, there is Eat Client Summit on Thursday. There is many events where you can meet people from the client teams, from the ecosystem, interesting projects on protocol or your application layer. So please don't hesitate to talk to people, to meet them, even text them online whether they want to have a coffee in person. People are open to it. So yeah, use the opportunity because it's very special that Ethereum meets all in one place. That happens less than once a year, I would say. I mean, on average with COVID. So yeah, that also means, like what I said before, stay active, stay vigilant, stay active, stay visible in the core community. Most of you guys won't be able to find a position or long-term support right away after the fellowship, but it doesn't mean that you shouldn't stay here. Please follow up on your work. If you have any unfinished PRs, make sure that they get merged. Don't just abandon them. Make sure that everything that you did actually actually gets done. And if you see any other issues, any similar projects you might be interested in, continue contributing, showing up to ACD, showing up to the Discord, so people know about you, and you can meet them throughout the months and eventually stay longer in the core community. That's my advice for what comes next. But for today and for the rest of the week, just enjoy the city, enjoy Buenos Aires. I hope you like it. It's nice and warm, not like the most of the world. So yeah, I hope you enjoy that, and hope you are ready for the presentations today. And we made the schedule ourselves, so we chose the sacrifice of the first person for first people who need to present. So the first presentation is Nando, June. Yeah, if you guys are ready. Yeah, the stage is yours. Come here. Yeah, Josh, if you want to, we're good. Anything else?
No, just, yeah, looking forward to seeing all your presentations today. And yeah, let's kick it off here with Nando and June.
Yeah, let's do it. Hi.
Yep. Hello, hello. Okay, let me start. Yeah. Go ahead. Yep. Hello or hola, everyone. My name is June, and my great teammate Nando here. We're going to present about the SSC query language with Merkle proofs, and we all did this in Prism client. And yeah, so let's get into it. So what's the SSCQL in a nutshell? So it stands for SSC query language. It's a standardized and path-based query language for any arbitrary SSC object with Merkle proofs. So basically, you can get the results you want in a very you can easily get the piece of data from the SSC object with verifiability. So I'd like to note couple of things that SSCQL provides. First of all, is efficient. So traditionally, we have to fetch the full beacon state, which is over 250 megabytes, and parsing it with JSON or something, and then get the field that you want. And you don't have to, because SQL is here. So that's one thing that I'd like to note. And other thing is the verifiability. So there's a famous quote in Ethereum: "Don't trust the result, just verify." So with Merkle proof, several hashing, you can get the root and compare with the anchor root, and then verify yourself. And I think at this moment, I think on my head, I think there's a couple of use cases like light client. So light client should get the state data or on-chain data from the beacon node, but it has to verify as well. So it can use SSCQL and also validator or staking services. Like what if Lido wants to get some virtual credentials with verifiability. And I think the SSE is a core building block in Ethereum, and I believe it will be a core. It will get much power if the time passes. So I think the SSQL is quite useful in that context. So yeah, here's a real-world example. So Alice wants to fetch a virtual credential for 40-second validator. What she can do is just send a post request and with the data of the body of it, and then she will return this kind of object. And here's the result. The result is start with 0x00ac, which is the credential that she wants. And if it is needed, she can also prove herself with the proofs, Merkle proofs, and hashing several times. So yeah, here's the brief introduction of SSCQL. And let me go deeply into some technical aspects. So we started building this project in Prism, which is written in Go. So it means that we have to convert or analyze Go struct to some SSC information that we need. So SSC information contains about the what SSC data type for this object, how much length of the object, or which field the SSE container has, etc. So Prism has some ghost struct, and there's a couple of challenges that we faced it. First of all, we don't want to stick to beacon state or beacon block. We want a completely generic way to analyze something. So in this case, we used Go reflection, which allows a user or developer have some superpower analyzing the value in a runtime. And second of all, we want the code to be as simple as possible, which means easy to read, easy to maintain. So we use some recursive way, and I will show you in a minute. Yeah, so here's the entry point of SSEQL function. You can see that this function receives an object, which is just a pointer to an SSE object, and returns SSE info. And you can see the reflection here. We can get the value in the runtime and then put it into analyze type. And here's the analyze type function, and you can see each cases to call each functions. So I'd like to focus on the separating the interests of this analyzer. So for example, if it is struct, we can assume that it is a SSC container type and then call analyze container type, etc. So here's a real-world example that we did, that we analyzed the beacon state in the mainnet. So you can see the total size is over 270 megabytes, and there's lots of information here, like which type of the field is, the total size, and the offset. So suppose we want a proposal index in latest block header. We can just slice the full serialized beacon state starting from 72, 64 plus 8 is 72, and just slice it as a length of the 8 bytes. So yeah, it's simple. We all know about the information that we need to get the exact data, exact piece of data that we want with this SSQL engine or analyzer. And yeah, so from now, I will pass my baton to Nando, and he will explain about how do we integrate this Mocha proofs with the results that I presented.
Yep. Thank you. Hola. So I'm going to talk about the Merkle proof integration in Prism client. And we need the Merkle proof because we need to prove the inclusion of the element requested in the object. So for getting the Merkle proofs, we need the Merkle tree hashes and also the generalized index. To get the generalized index, we have the path and the SSE info object that has already the information from the analysis of the SSE object. And the path contains the sequence of elements to reach the terminal element requested, and the SSE info object contains the data types of each of the steps. So thanks to this, we can walk all the steps, compute the contribution to the generalized index step by step, and accumulate them all. In this slide, I show this formula from the is2 spec because it has been the source of truth for all the testing in this implementation, and we have worked a lot with the executable specs. Well, in relation to the Merkle proof production, we analyzed the different ways of implementations, and there were a few. One of them was to rely on the state native proof that they are already in Prism client. So in Prism there are 3 proofs from the beacon state: the next sync committee, the current sync committee, and the finalized route. And we could extend that to get all the needed proof for the beacon state. The problem with that is that it only works for the beacon state. For the beacon block, we would need another way to generate those proofs. And also, we would need to, so those proofs are only for the top level fields in the beacon state. So we would not need to develop a way to get the Merkle proofs for the nested field. As a matter of time, I opted for building the recursive proof. So for any given SSE info object, we can issue the Merkle proof in a recursive way. We can build the Merkle tree and with a custom hasher and record the Merkle hashes. So once we have the generalized index, we can get the proper hashes. So, well, this is an example of the recursive algorithm. This is the main dispatcher, the build root from type, and it redirects execution to the proper root builder based on the type. And this is just the rapid summary of the whole process. So we get the generalized index from the path, we issue the proof, after that we prepare the response for the SSE query language. So the key takeaways from our EPF, I guess that they are the great communication we've had. June made amazing great apps. You have already read them. And we have also collaborated all together. We had weekly syncs to share our progress. We have talked a lot in between us and also with the mentors in our Discord channel. And also the methodology. We spent a few weeks at the beginning designing the SSE query language. After that, we went coding, making prototypes. Jung went to work on a prototype in Golang to show the feasibility of the reflection analysis and everything. And I went to a Jupyter notebook to give some visibility to what we were doing. And after that, we worked on the implementation. For the future, I guess SSE query language need to be extended. We need more functionalities. We need to filtering. We need to add multi-queries. We need to add multi-proofs. So there are a lot of room to keep working on this. And also, we would love to have a full formal specification. We've been working on it a little bit. And also, June started to push for adding these two endpoints of SSE query language in the Beacon API. So, well, thank Bastin for having us and for mentoring us and supporting us in every way. Also, Manu. Thank you very much.
All right, thank you guys. Great presentation to kick it off. Let's see, next up we will have a present. Oh yes, are there questions? Sorry, thank you. All right, Gaiman.
Do you have any examples of like a dynamic proof, like getting like the last validator's balance or something that's not where you don't know the G indices ahead of time? Yeah, do you have an example of like a proof for like, or a dynamic proof where you don't know what the exact shape of the proof will be ahead of time?
But, yeah. Well, I think we can get the length of the validators list. And from that, we can issue the proof for the length. And after that, we can issue the proof for the balance, maybe?
Yeah.
Okay. So that could work with SSE query language.
Okay, so you would just do one query for the length,
yes,
and then one query for the balance.
So far, we have to do in several steps, but we want to add multi-queries, so we can concatenate different queries. And that would be only one query to the SSE query language.
Maybe we can add like -1 index for the validators, like Python do. So that's one of the possibilities that we can take.
Any other questions? Awesome, thank you. All right, next up we have Odinson to talk about clicker, so many things. To talk about state caches in Lighthouse. Let's give him a round of applause.
Hello. Yeah. So, hi everyone. I am Odinson, and today I'll be talking about the project I worked on in this Ethereum Protocol Fellowship, that is memory-aware caching implementation in Lighthouse. So, first of all, thank you to my mentors who are unfortunately not here, Michael Sproul and Daplan. So, let's get started with this. So, what was the motivation behind this project idea, that memory-aware caching implementation in Lighthouse? So, first of all, thank you to Ethan. I just took this image from your blog of Sigma Prime. So, let's get started. On February 24th this year, while going through the path of upgrade, Picta upgrade, what happened is that Holesky justified and finalized an invalid block on the chain because there were misconfigured deposit contact addresses on 3 of the major execution layer clients. What happened after that is a period of prolonged non-finality, where the consensus layer clients were unable to build and attest to top of this canonical chain. So that led to this period of non-finality, and during these situations, there's this thing called inactivity leaks, which kicks in after the beacon chain is unable to finalize up to 4 epochs. So this inactivity leak kicked in, and this was especially hard for Lighthouse because the inactivity score was not optimized. So for example, normally what happens that I'll be talking in the next slide, each beacon state stores about 200 megabytes of data. But during this time, after every epoch, the inactivity penalty for every validator who were not participating, that increased by about 70 megabytes. So you might know how the Lighthouse database works. That is, they have this hot database and a freezer database. So the hot database was unable to migrate to the freezer database, some of the states, because of this non-finality, and it ballooned up to 1 terabyte out of memory situation happened, and while serving these non-finality states. So this was the Picta-Holesky incident, on a high level, what happened. Next, there comes my this project idea that before I talk about my project idea, currently how does the caching work in Lighthouse? So Lighthouse uses a fixed LRU count-based caching implementation. Back then it was a total of 32 states. Currently it's 128 states. So normally what happens is that it's about 500 megabytes to a GB in normal conditions. But when situations like non-finality comes, each state, which as I mentioned around 200 megabytes of storage, they get increased to about by 70 megabytes because of the inactivity scores and the penalties that kick in. As I mentioned, about 70 megabytes in inactivity stores, and all of these 128 states, beacon states, they just take up a lot of storage, and that can go up to multiple gigabytes to a terabyte. So this fixed count LRU cache is good for normal situations, but it does not tell you how much of the memory is being used in this caching. How many bytes is the cache actually using. So this is what led to the inception of this project. So how did the design come about for this? So Lighthouse, Sigma Prime has this persistent binary Merkle tree library, that is Millhouse. So we used Millhouse. So basically Michael had a prototype of this Millhouse's memory size and memory tracker implemented. So I implemented some of the nested lists and stuff in Millhouse. And on top of that, we implemented memory size in beacon states, creates types create, and we used a single memory tracker to calculate the entire size of a beacon state. So the main thing for us was that to know how much actual memory is being used by the beacon state. After that, the second point was we needed to make the state cache memory aware and not just focus on the number of states that it stores. How did we do that? We used a new max cache bytes field in the state cache struct. Then what we did is that we did not like compute the memory after each insert or deletion. That would be like a long CPU overhead. What we did is that we used a simple insert counter. After, let's suppose n inserts, which is currently 10 inserts, what we do is that we have this function recompute cache byte. What it does is that we recompute the entire like memory size of the beacon state, and then we prune when the memory size is above the byte cap, and it goes on till the memory comes down up till the byte cap. And finally, for operators, we expose some CLI flags so that they can look at how much of the memory is being used, how much time does each item and versus the entire beacon state take. So yeah, talking about the approach, as I already mentioned, in beacon state memory size calculation, I implemented Millhouse's memory size for the beacon state memory calculation. Now, when we're thinking, why do we need Millhouse or this memory tracker? So, by this beacon state, it's not like a linear object. It's like a big Merkle tree-ish object which has many nested loops, lists, and other structures. So, because of this, we needed something that can, because of this reason itself, a lot of the times, many caches or other stuff, they have this shared memory tracking via ARC. So we don't want to track all the shared structures as well, because that would lead to calculation of how much of the memory would be stored if none of the structures were shared. But we needed an actual value of how much of the memory is actually stored in this beacon state. So we use this single differential memory tracker for the shared ARC data. The next thing comes is making the state cache memory aware. We used an option. So yeah, one of the thing is that this max cache state cache bytes, this thing is optional for operators to choose, if they want the current count-based caching mechanism as it is going on right now, or do they need this memory aware caching. So we have this optional max cache byte limit alongside the the existing count limit. We track the cache byte as the last measured total bytes for all the cache states. Now, as I mentioned that after a total of n inserts, we decompute the cached bytes, and if the memory is above the byte limit, for example, if I use the byte limit of 8 GB, so if the memory is going above 8 GB, something like that, something that happened during that incident, it will prune, and it would then take cycles to come down below that memory cap. So yeah, as I mentioned, if the cache bytes is more than the max cache bytes. Now, how is the max cache taken? So it is provided by the operator who is running the node, or the validator client. They just provide the memory that they want, the memory cap, for example, 4 GB, 8 GB. So if the cache byte is more than that, the pruning kicks in. If it is not, it performs like normally, it keeps running. And after every batch, it runs the recompute cache bytes again and repeat until it's under the cap. So it is let's talk about how it helps the operators. So we exposed a new flag that is the state cache max MB that is disabled by default. It is optional, and it can be used by the operators to say they want the cache to be memory aware, and they can use this while running their nodes. Other than that, we also have this memory calculation time histograms that shows how much each item versus how the entire beacon state stores the entire, uses how much time it uses to calculate this memory cache. So yeah, let's talk about benchmarks. What are the benchmarks right now if there's no byte cap in the Lighthouse caching? I hope you can say this. So under normal conditions right now, if we to mock the situation of non-finality, I ran this and spammed HTTP requests to bring to this situation that you can see like the total node memory that is used is around 50 GB. It also ballooned up to 70 to 75 GB at times. And during that time, the entire state cache stays to 128. That is by default. So it like so this is the normal situation that happens, and there is no way to know like how much memory is being used, how much is the cache using. So apart like versus this, after my implementation, this is how it looks like. So you can see, so I put the cap of around 7.5 to 8 GB. So here in the total memory used in the state cache, it says around 7.5 GB. But what you would see is that right now the number of states stored is 65 instead of 128. So this is the change that happened. If each beacon state balloons up in its size, so it won't store all of this data, but it would like prune until the data is below the cap. Other than that, you can also see like previously, the total memory that node uses was around 50 GB or like it was even more. But right now, it goes below because of the pruning and because of the cache pruning that happens. And it's around 40 GB. It also like goes around 35 to 30 GB, which also like helps this case against what happened previously. And one thing that I would come to, one of the trade-offs that used to exist is that the recompute costs, like for a full scan, it goes around 15 to 18 seconds. And for one core, like it uses one core's 40 to 45% of a single core during this entire recompute. So yeah, let's talk about trade-offs and the limitation of this. There's a reason for which my mentors told me that to keep this thing optional for the operators to choose, because the main thing was the pruning takes a lot of time. As like binary, there's a beacon state is already huge, and calculating its memory, it takes a lot of time, and also like the pruning, it leads to CPU overheads for periodic scans. Even if it is not done after every insert, still after n inserts, it takes a lot of time and the CPU overhead. So yeah, also like the second thing is that pruning can increase cache misses. And how is that? Now, if in the hot database, the first example, as you saw, that the number of state caches went down from 128 to around 65. So the number of states that are stored in the hot database are low. So this leads to database misses, like in these cases, and it leads to cache misses as well. And yeah, the recompute and pruning takes a very long time, as I mentioned. Because of this, it is currently like optional and can be chosen by whoever wants their caching while running the nodes to be memory aware, and not just based on the number of states that it is traditionally or like currently. So yeah, that was my presentation. I have attached some links. Ethan's blog about the Pictor-Holsky incident, the postmortem, my project proposal, and the PR that currently is like I'm working on. So yeah, thank you. That was my presentation. And any questions? Sure.
I wonder if Lighthouse, like, is it storing full states in this cache, or do you share like the validators at least? Because like a lot of the state doesn't change between individual states, right? A large part is unchanged.
Like, can you say repeat?
Yeah, like inside.
Like, is Lighthouse using partial states in there, like sharing the validators list across all of these 128 states, or
Yeah,
why is it so big?
It doesn't use all of those, but some of, like, for example, committee caches or epoch caches that they use, which are essentially, I believe, are not on-chain. So, and like the shared data that is being used, like via ARG, that we run the single differential memory tracking so that it is not like used time and time again every time it comes around.
Okay, thank you.
So you said pruning is slow. That's why it's optional for validators.
Yes, the pruning, like it takes a lot of CPU overhead, and like because of the beacon state is nested structures, it's pretty slow. That is why it is optional for now.
Okay, so it's optional because of the so much work it takes, or it's optional because it's blocking? Is that the case?
So the decompute, it happens while like the insertion takes place. So because of like any, to avoid any deadlock and stuff, so that is why it is optional right now, because if the insertion happening and like it is not on a different thread, so because of that reason.
Oh, so it can't be possible to make it on a different thread or something?
Yes, it is, but like for the current scope, we discussed about it and like we decided to like keep it optional for that reason itself.
All right.
Can you talk a little bit more about the way you tested, like simulated a non-finality for testing this specific thing? You said something about making a lot of HTTP requests.
Yes. So I ran the Lighthouse node, Lighthouse and Wraith node, and then I believe the committee cache and beacon state like sidecars, I like spammed the HTTP queries, and because of that thing, like the state cache misses happened, and by that.
Makes sense, thanks.
Last question.
Yeah, hey, sorry. So can you explain a bit more about the cache state misses and what the implications of that are?
After the implementation?
So you say when you prune, that can result in some missing.
Yeah, so what I mentioned is that currently in the hot database around like, in the current implementation, 128 states are stored in like in the cache, but after the memory-based pruning, like once the pruning happens, as you saw that it's around 65, or like it even goes down, like even in cases of extreme situations, around only 20 to 25 states are stored. So while looking up the states, so in that case the state cache misses happen because it is not in the hot database present. So that is what I meant.
Okay, so what's the implications of that?
It could lead to like slow lookups, and I mean,
Because it's got to go to the cold.
it needs to go back to the disk, and like in the freezer table, I believe I might not be able to answer it like clearly.
Thank you.
Awesome, thanks. One more round of applause for Odinson. All right, next up, we got Shane talking about EPBS.
Testing, great. Hi everyone, I'm Shane, and this talk is about taking Lighthouse from no EPBS to DevNet is actually in sight. And a quick about me is I've been building professionally in Web3 since 2022. I was previously on the core team at Injective Labs, a Cosmos SDK-based L1 focused on finance. Why EPBS matters at all? Well, during the cohort, I wanted to focus on something that was going to move the roadmap forward. And as Vitalik mentioned yesterday, we're really focused on scaling the L1, and EPBS does just that. So currently, we have to process a payload in 100 milliseconds due to like the 4-second attestation deadline, right? Well, with EPBS, we're now going to have much more of the slot to be able to process an execution payload because we're actually decoupling the payload from the CL block itself. So much more time, fatter blocks. If we want fatter blocks, we need EPBS. If we want EPBS, somebody has to build it out. So I had 4 main goals during the cohort. 1, move the roadmap forward. And also, I wanted to get deeper into my consensus layer knowledge and really deep into the EPBS spec to understand its trade-offs. And also, I wanted to deepen my Rust skills as well in a live, like async system that's running. It was awesome. And I want to do all this in Lighthouse. So, started off by wanting to say, thank you, Mark, for being my fellow contributor and mentor for during the cohort. It was so much fun building this out with you. And we started off by focusing on DevNet 0 related changes, which were going to be focused on the self-building case and also without blobs. I was pretty impressed during the time together how well we were able to work on things concurrently and keep moving the needle. So my different phases that I worked on during the cohort were divided into 4 categories. First would be all the new containers that we would need for EPBS per the consensus spec. And then afterwards, I followed up with a lot of the state transition functions that we would need to be able to handle. And next up would be validator client updates. And finally, the P2P changes that would be also helpful to implement. Phase 1, it's all related to containers. Oh goodness, it was such a big effort, maybe 1,000 lines of code. We added like envelope containers, we added bid containers, payload attestation containers, and I wanted to highlight on here that we actually removed a little bit of code, right? Like the beacon block body no longer will have an execution payload since it's decoupled. The beacon state will no longer have a latest execution payload header. And whereas these may seem like one-liner changes, you can just imagine how many downstream functions were impacted and the amount of changes we had to make to keep code compiling. So with this step, I then finished with fixing up some tests to keep CI green. And in summary, yeah, no containers, no DevNet, right? Next phase would be the state transition functioning. The beacon node is the engine of the consensus layer, and it handles all of the state transition functions and state processing, right? And here you can see that we have payload attestations that are included in the consensus block. So during block processing, we're going to run process payload attestations to be able to grab the bit vector that's contained and map that to the PTC members and be able to check whether or not they actually attested during that slot. So we can now, and also do the signature verification as well. So on the right, it's just a small example. We can say, all right, we have the bit vector for these particular validators. We can sort, index them, and be able to tell, yes, they actually did attest during the slot on time. Another fun one was building out a PTC cache. To be able to get a PTC committee from the beacon node is actually a heavy bit of computation. So I built out a cache that is basically a flat vector with 32 chunks with 512 spaces per chunk. This allows you to be able to know if it's this slot, these are the PTC members that were responsible for testing during that slot. And inversely, you can do a reverse lookup with a hash map that I created that tells you for which validator index, which slot will they be in, which gives you O of 1 lookup times, which is quite convenient. So I just wanted to make it to where you can run this cache at the beginning of an epoch, as opposed to, say, per slot, yeah, to keep it off of the hot path. Phase 3, validator client. The validator client is the driver of the consensus layer. This included a few different fun aspects. Let's go into them. I built out a payload attestation service. It wakes up at 3/4 of a slot to be able to grab payload attestations from the beacon node. It will do one single GET request to fetch them all. It'll be able to sign all of the payloads in parallel, and then do a single batch post request for all the validators that are held locally in a validator client. So most of the main wins here were trying to keep network calls low, and I also use some asynchronous reference counter to be able to keep clones cheap for this service. It felt like that was nice optimization from a memory perspective. And this one was really fun. When building EPBS in the validator client, I realized that there wasn't any Beacon API spec for any of the EPBS endpoints. So I opened up a PR, and that included, payload attestation stuff, all be able to get bids, be able to post bids, maybe 10 different endpoints, and also modify produce block, make a new produce block v4. This effort was quite fun because it unblocks all the different consensus layer clients when building out EPBS, not just Lighthouse. So very, very happy with this. And phase 4 was P2P changes, a tackle like gossip sub and also some RPC changes. For gossip sub, like execution payload will arrive over the wire through libp2p, end up in Lighthouse's network crate, and then go through the router and end up in the beacon processor to be able to like be queued up and used in various services. And also on the RPC side, I added execution payload, get execution payloads by range. So that way you can get like many execution envelopes without doing a bunch of single calls. You can request a range of them. So that will be useful during backfill sync specifically. And additional PRs is just a long list. I would go into them, but that would take another hour. So let's skip that. Here's like my total contributions so far. We have 10 merged PRs to SIGP Lighthouse. We have 5 that are still open and 7 that are in my local that are just ready to be upstreamed when the time is right. And as I say, stay tuned for more. Yeah, so where are we at? DevNet 0 now hinges on a few different phases. We want to be able to handle payload attestations and payload verification during block validation. And then we'll probably move on to some nice DB refactors since no more blinded payloads, right? Or blinded blocks. And then finally, we'll do all the 4-choice modifications, which will be a beast. Oh, and then we're going to be thinking probably about mainnet. How do we get there? We'll get back in the car and start driving towards mainnet. Reaching mainnet then requires us to build out the in-protocol builder into the validator client, and also all the builder API changes that will be coming soon. And then we can move on to be able to how we're going to handle blobs in this new EPBS world, and finally do like ruthless end-to-end testing. So yeah, I want to do a nice like shout out to a bunch of folks. Josh and Mario, obviously, thank you so much for leading the cohort. I think I could say on behalf of anyone who's ever done the EPF, thank you sincerely for doing this. Yes. And yeah, no, thank you. On the Lighthouse side, I want to say thank you again to Mark. Been having so much fun building this out with you, man. Really been a totally great time. Let's keep it up, keep up the pace that we're at. Awesome. And Ethan, thank you for joining the EPBS track as well. Happy to have you on board. And Sean, I want to say thank you as well for moving me towards EPBS, nudging me towards it. Total game changer, man. It's been awesome. And also all the guys in the ETH R&D Discord and like EPBS breakout rooms for answering my new questions along the way. It's been a long journey, but it's been great to get all the puzzle pieces together in my head of how this thing works and actually, implement the PRs and whatnot. So thank you again. And yeah, in summary, EPBS is on track for Glamsterdam. So let's do this. Yes.
Any questions for Shane?
Oh yeah, questions, sure. Yes.
Why is EPBS part of the scaling roadmap?
Why part of the scaling roadmap? Because currently we can only have like relatively small blocks, which is due to only having about like 100 milliseconds to be able to process a block before hitting an attestation deadline at 4 seconds into a slot. With EPBS, we're taking this payload out of the attestation like deadline issue, and you can then process transactions basically up until maybe say 9 seconds or so, and then have to attest later. So yeah, bigger block, and it's essentially scale. Yeah. Okay. Yes.
Hello. Yeah. Thanks, Shane, for a great presentation. And I would like to ask about the Beacon API proposal. And so for our team, we would like to also propose Beacon API. And is there any advice for as you propose earlier for that project? So yeah, I'd like to hear about that. Any episode or any comments or advice?
Yeah, I mean, first thing was just checking if anybody else was like working on the effort already. So just posting into EPBS channel, like, hey, I'm thinking about adding this because I actually need it for my validator client work. Anybody doing this? And the answer was, no, go for it, man. And then the rest was just making a PR to consensus specs. It is a bit of a learning curve, like to the Beacon API specs. It is a bit of a learning curve to figure out how like all the formatting works within there. But you can see many, many examples within the Beacon API. So I think that will move you forward. And as I mentioned, I got like 90 PR reviews for that one. So yeah, thank you all the core devs that reviewed that PR. It really made a lot of difference for me leveling up there. And yeah.
All right, one more time for Shane. Okay, next up we have Rahul, who will talk about ERA files in Lodestar and some other things that he did in Lodestar.
Yep. Hello. Hi, I'm Rahul. I implemented ERA file support in Lodestar. Yeah, though it's not complete yet, and it's quite a low priority issue, but I also did some Zig stuff along the lines. So yeah, let's talk about the problem statement. So CL clients still store and offer. Hello. Offered the entire beacon chain history for someone who wants to sync from Genesis, but it's still a few terabytes, and we can use trusted checkpoint, but that kind of exposes us to weak subjectivity attacks. And they also need to store the data for about 5 months. And also there is no standardized way of sharing the data except for the P2P network and outside of the specifications. So what exactly are ERA files and how they might help to solve this problem? So ERA files are a flat type length value file format for finalized chain data. So what exactly are type length value for file formats? It's basically a type of encoding where it starts with the version of the file, and then how much data is in the file, and then the actual data itself. So what exactly does ERA contains? It contains a version marker, the actual blocks, the beacon state, and the indices which can be used to do a lookup search on the exact data. Indices can be basically used to look up the data from a block via slot. Yeah. So every ERA contains 8192 slots. It's basically about 27 hours of chain data, and also ERA files can be verified by using the block signatures, and they can be also verified using historical roots from the beacon state, which are like more than the ERA period basically. And yeah, it essentially reduces the nodes to store all the historical data, because they can just download it from a single peer who has the data, and it can be validated on the go. So what's the current status of my project and progress? So there is a ERA package that's implemented in Lodestar that contains the reading and writing of the ERA package. And other than that, I encountered some spec test bugs on progressive lists, but it's kind of fixed by now. But yeah, I mean, the level DB integration of the ERA files that it needs to consume and it needs to produce, that's still a work in progress, and yeah, it's kind of missing for now. So the thing was, the team was quite busy on Fusaka things, so I had to like jump on to other stuff. And recently, Lodestar announced that they will be doing a Zig TypeScript hybrid client, um, basically using the Bun FFI. So I thought it would be fun to contribute to the Zig aspects of it too. So I saw that there were open issues regarding implementing progressive types in SSZ. So what exactly are progressive types? It's basically so the problem with SSZ now is that with every new hard fork, when new fields get accepted into the spec, the Merkle verifiers, they kind of break, and there is a lot of redundant padding also in the SSZ. So progressive types kind of help in that. Uh, s- uh, in So essentially what happens is that yeah, so basically what happens is that a new Merkle tree is kind of introduced that will introduce that introduces subtrees so that we decreases the padding, and when we add new data, then when we add new data, the Merkle proofs don't change basically, and the G indexes says the same. And also, I asked K-Man if I can work on other Zig stuff, and he recommended me to work on the state transition function in Zig. And yeah, I mean, I looked into and I implemented the Fulu specs for the state transition function. The main contribution there was probably the deterministic proposal look ahead, even though it was not quite such a big PR, because what it essentially does is it recomputes the proposer so that it can be used in the later slots. Uh, yeah, I mean, that's all, and these are the useful links that can be used later on. Thank you, and any questions?
Questions for Raul? All right, thank you. All right, next up is Vedant, who will be talking about backfill sync with Lodestar. Maybe? Do we not have Vedant here? All right. All right, we'll move along to Irene then, who worked on some kurtosis migration in Lodestar. All right, looks just behind.
Okay.
It seems like we're having some technical difficulties. Yeah.
You know why? Probably because I have uploaded the presentation as a PDF. Because I downloaded it as a PPTX. It was horrible. Like, messed up all the graphics.
Okay.
So I re-uploaded it again. But finger crossed it's not a PDF.
Okay. You broke it.
I broke it. Ellie is not here. Ellie, other girl. No. Maybe because she's.
Okay. Yep. All right, Irene.
Doesn't work. Doesn't move through the effect. Ah, yes.
Point it this way, not at the TV.
technical issue. Is it working? Yes, technical issue solved. So hi, I'm Irene. I did my project on Lodestar, specifically the testing framework. And yes, the title is Lodestar SIM test migration to Kurtosis. Context and goal. I started with the question, can Lodestar testing framework built to run locally orchestrated Docker jobs migrate to Kurtosis without changing the test logic, assertions, or the developer workflow, and maintain the backward compatibility? Context. So Lodestar works originally on Docker jobs and assertion layers. Kurtosis is a testing infrastructure platform that runs multi-node testnet in isolated enclaves using declarative starlet packages together in combination with the Ethereum package developed by the EPF6 team. So the most relevant component at that time, pre-migration, was like the runner, Lodestar runner, which is responsible for orchestrating the processes and all the whole life cycles, the nodes. Basically, what does Lodestar do? They create the execution beacon and validator node and assembles everything into the node pair. The tracker report, which is the simulation output, which is a table that contains all the logs about the simulation. And since there was no fixed blueprint, so it was like a research project, I just followed the reverse engineering approach. So basically, my goal was to swap the testnet orchestration from Docker to Kurtosis SDK and Ethereum package, which basically means implant the Kurtosis SDK under existing architecture. So we are going to keep the existing assertion framework untouched, and also the existing node pair structure and the simulation tracker. Those were the migration entry points I discussed with my mentor, which is Nazar. And basically, we started refactoring the iRunner interface, so starting from Docker and switching to Kurtosis, introducing Kurtosis specific type, which is like the Kurtosis network config and the Kurtosis service map. The clients folders, so these folders inside Lodestar will be completely removed, and the assertion inputs, this is the key, the node pair, is going to remain the same. And this is what the multi-fork test, so one of the Lodestar tests is going to change. So from this imperative declaration to a more like this type of declaration with the YAML file from Kurtosis. So we are going to like remove all of the beacon and node and definition using just one single file. Migration structure. This is the whole overview. So we are going to start using the Lodestar simulation. We are going to create a Kurtosis enclave. We are going to spin up all the network using and defining all the network specification using the Ethereum package. Kurtosis services endpoint will be generated, so we won't rely on Docker anymore, but we will just rely on Kurtosis services endpoints for the beacon and all the RPC endpoint. This endpoint is going to be translated into a node pair array, which is going to be consumed by the assertions. So the simulation table report at the end is going to run untouched. Migration process, a bit of code here. So Lodestar works with Runner. I just adjusted it, creating this new Kurtosis SDK runner, which basically is the communication with the Lodestar testing framework and Kurtosis SDK. As I said, it's a reverse engineering approach, so I recreated everything that like Lodestar already has using Kurtosis, and so I just followed the three-phase life cycle, which is like the initialization of the simulation with a start, network deployment, spinning up all the network with the Ethereum package, and the cleanup, so the complete removal of the enclaves. This is the core of the whole project, which is basically adapting the services that Kurtosis creates to the node pair array of Loadstar. How did I do that? Basically, I created a service context I created like then helper function, which is create node pair from kurtosis. Emulating the create node pairs, I construct the API clients from discover port exposed by the kurtosis services. I build the node pair structure matching the Docker output, like here. So before, this was based on Docker jobs. Now we have it based on kurtosis. And the output, like the return, is a node pair. So completely compatible with the assertions. At the end, as I was explaining you before, I did the same stuff that kurtosis did, creating the beacon execution and validator node, but from kurtosis. Yes, I put here some example of how was it before and how it is now with kurtosis. This is the YAML file I was mentioning before. Basically, a YAML file is a declarative network configuration consumed to deploy the Ethereum testnet inside a kurtosis enclaves. On the left side, you can see the Loadstar node. On the right side, this is what the multi-fork YAML looks like after the migration. This is the final workflow. So we started with the type network config, the kurtosis type we created from scratch. We ran the simulation running the kurtosis SDK runner, so runner.start create, the Ethereum package where all the kurtosis services got deployed. We create the communication between kurtosis and Loadstar. We start the simulation. Simulation also is from Loadstar, is not from kurtosis, so it's a hybrid approach. And then we use it as an input for the assertion layers, which remains completely unchanged, and then we stop either the simulation and the runner. And then we got like we get to the simulation output. Results and output. Of course, this is just an experimental like research project. So far, the results are pretty promising. On the left side, we can see the table report of Loadstar. On the right side, we see the kurtosis report, both running the multi-fork test. They are kind of similar. I think that like in the next 6 months, I'll be able to like find out if I reach the one-to-one parity or not, but this is the current status. So the multi-fork test is running with kurtosis. The node pair conversion seems solid. The YAML file is also syntactically correct. One thing, I kept the sync assertion from Loadstar commented out because I'm still working on that. So it's one in the to-do list. So what's next? As I said, I will continue contributing to the migration also after the fellowship. I'm going to improve the Genesis time synchronization, as so far is still hybrid. So half is relying on Loadstar, half is from kurtosis. I need to sync it. Migrate the sync assertion, as I was telling you before, and test the other Loadstar themes test, because so far I just focus on the multi-fork. So for example, the neb and another one. Thank you to, of course, everyone. Thank you for like accepting me as a fellow. So shout out to Josh, Josh, Mario, my mentor Nazar, Matthew also from Loadstar, and the whole Loadstar team for like welcoming me during the stand-up hour. And congratulations to you guys. Time for question, if you have something.
All right. Thank you. One more time for Irene. Next up, we've got Vukasin, who's going to talk to us about Tokyo tracing in Grandine.
Hello guys. So in next 15 minutes we are going to talk about Tokyo tracing integration into Grandin consensus client. My name is Vukasin Markovic and my mentors were Saulius and Thomas. So future. Something that are all of us curious about. Constantly new updates, new feature, new hard forks, Fusaka, and everything of that sounds great, and everything of that is great, and everything of that bring trust and in our builders and users. But everything of that also make Ethereum the best network and technology today, but everything of that relies on you guys, execution and consensus client, in general protocol engineer who makes everything possible. So it's better for you not to mess things up. And in handling that pressure, we will agree that observability is a must-have. So let's show one of clients who needed that observability. It's Grandin client, high-performance one, when everything needs to work fast and everything needs to work well, and it really works. But there are constantly new feature, new updates, new release, and there is always but. So tracing. Our base for that observability. It is, and for now, I want from you to look at the tracing as one part consisted of two sides. First, applicational side, which emit events, and at first it was just logs. And second one is a subscriber side, which receives or act upon those events. And it functions on a concept plug and play, where you can plug one particular type of event and register, subscribe to them, and process them in way you want. And I'm sure that you notice one more word in our title, and that is Tokyo. And that's one of the main things of this project. That is asynchronous runtime in Rust. So tracing is also beneficial in asynchronous environment. Span is a concept which provides our tracing that ability, and it is a logical grouping of related events. So, for example, if we have one particular request or execute one particular test, we can select all events that are originated from it. So, because span is attached to it. Span can be also nested, but we'll talk about that later. So tracing in Grandin is consisted of few parts, and first is instrumentation, where we instrument our application and dedicate our event that spans. Second one is subscription, where we subscribe to those events. After that, we modify and process that in way we want. And the last one is forward it, because tracing doesn't actually need to do logging. And like we can do something more meaningful, like propagate that information to metric or some cool tracing backends and similar tools. So let's move to instrumentation. We instrument in Grandin peer-to-peer, HTTP API endpoints, validator duties, and a little fork choice rule, but a little. After that, our application starts shooting our event, and we attach tracing subscriber to that. Tracing subscriber function in a way it collects data from our application, which spans an event. It could also be modified by environment variable or at runtime via post API, but we will talk about it later. After that, it can process our outputs in a way we want. For example, it separates output on different output layer. it can also feed some analysis tool, which is like Tokyo Console, or feed some cool tracing backends and metrics. And how is it implemented inside? We have a standard output layer part and exception layer. Standard output layer part is the main one, and it collects all data that is shoot from our application. We have production mode, debug mode, and trace mode. So trace subscriber is implemented in that way, so we can enable one particular mode, not even per whole application. We could do that just for one module or one crate or any we pick. And of course, because a lot of clients choose in which mode they want to run their node at node start, and sometimes some error occurred after a long time, it's not so good to wait all that time to get that particular error. So because of that, we wrap our standard output layer with reload layer, and provide their tracing handle, propagate it through runtime, and now we could change that with simple post API requests through runtime. If we see our application again, we could, for example, if some error occur in validator duties, we can just third validator duties to trace mode and get more richer information from that moment. Of course, we have exception layer. Exception layer is something. Purpose of the exception layer is to collect something that is not really usual and not really connected to our consensus client. For example, we could get some error which is not particularly connected to our consensus client. To our consensus client, and we still need that information, but we don't want standard users to get spammed with that information, because that can be something malicious which happen on network. Because of that, we separate that output in a secret file and store it into grounding consensus client. So in case some error occurred, our client still can write to us and provide to us that secret file. Because the last thing we want is to, exception logs are not really common, but the last thing that we want is to exceed our memory limit with those exception logs, if, for example, network fail or something like that. And because of that, we there implement file rotation, where we fill our first file with threshold of 1 GB, and after it exceeds 1 GB, it will just rotate into another one, and we can keep up to 4 or 5 files, which will be compressed. So we have now we can keep up to 5 GB of our exception log data stored in just 2 GB. With forward traces, we have a lot of cool tracing stuff. And first is adaptive telemetry. That's intelligent filter, which keep just valuable traces. And that is great for saving our memory. But for speed, it isn't, because our trace subscriber still proceed all information. And because of that, we implement previous stuff with runtime change. Tempo is one of the coolest tracing backends for now. And it provides some cool tools like TraceQL, which is tracing query language based on concept on Prometheus query language. And we have Tempo MCP, which is newest thing in Grafana. And that's AI integrated query language, so you can speak with your traces on native language or English. You could just ask it, what are my services and what services have error, and we make our traces compatible with that. Flame graphs is traces visualization. It's the basic one we all know for flame graphs. And Tokyo Console provides a real-time insights into async task, and it's useful mostly during development. And with all of that, we could now go in much more release and much more hard forks, such as Fusaka, with less worries. Thank you. This is my work. You can find roadmap because tracing integration is a little bit complex because it's such a big project and touch almost every file. So you have a great roadmap where you can merge your code into production at every moment, and it's implemented in 9 phases. So if you want, you can look that. And questions, if there is any.
All right, thank you, Vukas. And
thank you.
All right, next up is Lee, talking about some Rust KZG.
Should I bring also? I can also bring my laptop. But actually, we are ahead of the time, so in the folder, Rust KZG. Sorry. Yeah, I think it works. Okay, just we can have a chill a little bit after so many intensive talks. Hopefully your brain is still working. And we are going to an even harder one, so let's hopefully you guys have a good luck. Yeah, amazing. Yes, Mario, you're amazing. Okay, hi, I'm Lee, and I'm here to present my work during the EPF cohort 6 on Rust KZG, and both the tutorial and also the performance optimization, especially focusing on the multi-scalar multiplication, which is a very crypto intensive thing. And okay, KZG is actually widely used in everywhere in Ethereum nowadays, and actually intensively, heavily used, like in zero-knowledge proof, in data availability sampling, and maybe later in worker tree and many other applications, because it has so many good features. But it also has some challenges, because Rust KZG is now the, according to the performance and the benchmark, it's the best implementation until so far. But I found it has 2 issues now, or 2 challenges for developers and users. First, it's pretty hard to understand what's going on in the repo, and without a very detailed document. Considering the Rust KZG itself is already a very complex project, and you are learning directly from the code, would be frightened for many, users. And also, I want to say if there is any possible to improve the performance of the Rust KZG, because any tiny improvement here can change dramatically in the whole application. Because for any application, you use KZG not just one time, you use many times. So here, I did two things with two tracks. The fundamental one is a tutorial book, which I hope I had when I started this cohort. And it took some time to write it. And also, all the chapters has very detailed explanation and also the example code you can run with Rust. And we have like 20 chapters now, and it's on the Gitbook. The second track was optimization. So basically, the Rust KZG has two major time-consuming operations. The first is FFT. The second is MSM. FFT is already highly optimized because it's like I checked the code, and we also discussed with a mentor and also other researchers in the field. It looks like now if you have any improvement with FFT, it's gonna be a huge news for both academia and industry. But then I take a look about MSM. Unfortunately, it's also highly optimized in Rust KZG. I will show how many times I failed in the choice, and hopefully you will never enter this situation. But during like a few weeks ago, during office hour with me and my mentor, Solis, he mentioned something very interesting because we are targeting a specific scenario for the data availability sampling. So maybe we can leverage some features from this scenario to make optimization for that. And it turns out it works. I had the theoretical proof later. And for the first track, the tutorial, so it covers several steps, like four parts, from the foundation of the math, crypto, to the architecture, to the GPU acceleration, to the production. It's all based on the project-based, so which means I show you with the code, not the mathematical proof. So you can just run the code. You may not understand the math behind it, but you will be confident to use it later when you need to use Rust KZG. And also for the GPU acceleration, which would be painful for many people for the deployment. And also the Docker for the production. It's already available on the Gitbook, and I will share you the QR code later, and you are welcome to review it, contribute to it, and I'm happy to credit. Because the whole thing was native written in Chinese, and then automatically translate to English this early morning. So I checked the first few pages. It works pretty well because I also added the dictionary for the translation. So ideally, all the important parts should be correct. But I still hope you guys are expert for Ethereum. So to use it, to check it, give me feedback so I can also contribute to the English community. And we covered the topic like PeerDAS, which will be included in the next application. And the BLST backend, that's the most efficient backend until so far for the Rust KZG, and also the GPU acceleration. Also, like language binding, which is painful for, anyone use that, we know that. And also security and other parts. And then the next part is optimization. So MSM is something you don't need to think it's very hard. It's a very simple thing, actually. That's why it used like 1,000 times in any simple proof. So it does something like we have P, like points on the elliptic curve. That's also the trusted setup did. So we have from P1, P2 to Pn here. And what does it mean? The previous one. The multi-scalar multiplication, which means we apply the scalar S1, S2 to Sn to these points and then add them together. So it's basically like you multiply the points and then add them together. So in general, optimize this could be also extremely hard if you are targeting a general use case. But in DAS, we can leverage some features that's very nice features because we are dealing with very small number of points. No matter it's like 4,000 here we are using or like 10,000, it doesn't matter because compared with in cryptography, we are dealing with it's like 2 parts or something. So it's very small, which means we can cache a lot of things. And also, the points is already pre-known. It's the trusted setup, actually. So we reuse these points repeatedly. And if we can pre-compute something over the points, we can reuse them later. We don't need to do a lot of huge cache, because if you want to cache all of them, it's impossible, because the skylight itself is like the field size. It's like 2 power to the, I don't know the size here. It depends on the backend you are using, but it's like a number you don't want to touch. So, but before I found the right solution, as I promised, here's several failed trials. It takes me like several weeks. Try to micro optimization, window size, zero value initiating, and bucket memory. That was like the most promising one, but it turns out it didn't work. It makes things even worse, actually. So, which means theoretically a lot of optimization may work, but if it's not a huge improvement, it's just like percentage improvement for a huge system, for a highly optimized system like RustKZG, when you applied your optimization to the code base, it may be a highly probability to downgrade, to make the performance worse. So here is performance. You can see actually sometimes it's better, sometimes it's worse, and if I add all the features together, it's just like a 2%, 3% worse than the original performance. But I also open source this part for the macrobench. So if you want to try, you can try. If you want to add new things, you can also try it easily. So what's the right way to do so? Because from the theoretical part, we identify some very interesting thing. Because remember, the points we are dealing with is very limited, only 4,000 points. So which means we can do 2 things. First thing is we don't need to use the field. We can use like a signed digital recording. Like now from the 0 to like 4,000, we can use the value from the negative value to the positive value. Because on the curve, calculate the negative value is very easy. You just reverse the, not reverse, you just reverse the y coordinator here, and it's very cheap. This will give you like ideally the 2 times performance improvement, but also increase memory cost like roughly 2 times. And then that's the most amazing part, the endomorphism, which means in some situation, let's say scalar multiplication in the native field could be expensive. But if we can map them to another group, it could be cheaper. So we can say we can do that. We can split the 256 bits in 2 parts, and then we need to deal with half of them one time. And for the one of them, you need to map to another field. Then you can add them together. But this part, the good thing for this part is we only need to map the points, the trusted setup, to the other group, to the other field. So which means you can reuse it, and the size is just as same as the trusted setup. it didn't increase memory cost exponentially. So in total, it gave you 2.9 times performance improvement in the MSM, ideally. And here is a comparison. So you can see here for the second line is our methods. We totally eliminate the multiplications, and we add much more additions. But additions is way more cheaper than multiplications in the curve. And if we even take like a conservative number, like one multiplication cost is roughly like 250 times cost as additions, we still get this 3.9 performance improvement. And in the real benchmark, it may be increased, but maybe decreased. But this time increase will still be a good foundation to really have the real world test. Then for the future work, I hope to I now have the a theoretical proof of concept code for the. I mean, it's enough for the academia crypto publication, but I want to have it on the Rust KZG library, and then if it's improved, and get merged. And also keep the content updated with my tutorial, and hopefully you guys also can contribute and also use it. And also maybe try to have a client tools for KZG, which may be very interesting to try. And here are some blogs, papers I referred during the research. And the whole impact and the contributions are here. So also some learnings. Do not do constant optimization for the huge project. It doesn't work. It makes things worse. It's just a nightmare. And the teaching is the best way to learn. So when I read the tutorial, I found, okay, I thought I understand it. It's very easy, but when you read it, you find, no, you still have a lot of things to learn. And let's say it can be more. And also the community is very important to support you to be here. And I would like to thank to the EPF and also the community and my mentors and Mario and Josh, especially Mario. It's like teach me like hand by hand how to contribute to the open source project, something like that. And also like all these EIPs and the Rust KZG team. And here is a tutorial. You can scan it. You're welcome to use it. And yes. And yeah, and also links. Thanks a lot, Culture.
Any questions?
Nope.
Oh, I just have a quick question. It seems you have, I'm not sure if you have implemented, because you said it's kind of theoretical, but it seems that you should have done some coding, right, in order to get the theoretical value. But you said that it is to be implemented, if I understand
yes,
right.
because for the theoretical part, we need to calculate how many operations you need to use. And I have the code for that calculation. And usually for the, let's say, for the Fry paper, for all these papers, we started with that part. And then for the real implementation, because you know it involves a lot of other factors. So maybe the performance will not reflect the contributions of this part, because you cannot simply isolate this part to test your improvement. Sometimes you can, sometimes it's hard. But this is a foundation for the improvement, because if you didn't have this theoretical foundation, you do something like I did before, like micro improvement optimization. It just, it may not be work, but this one is like give you a direction. It should be work. The question is how much, and if your implementation will really achieve this theoretical bound, because it gives you the bound you can try to reach. But the challenge is how to do that, and that's also I want to do after the cohort.
Given with what you know, how many percent more in order to get it to to be pragmatically runnable?
Okay, that's interesting. I feel like it depends on it highly related to the backends actually. Because Rust KDG, the good thing is it support multi-backends, which means you only need to call Rust KDG API and you can use any backends you want. But which also means if you want to improve anything, you need to consider multiple backends. For the NF optimization, I feel my personal feeling is it could be easier than the second one. Because the second one is like you need to pre-compute the endomorphism and you need to make sure the endomorphism works for all these different curves. But for the first one, it should be applied to any curves as we know we are using today. So I assume like few months for the first optimization should be fine. And the second one, I don't know, maybe takes a longer time, maybe shorter.
Thank you. Thank you.
Yeah, thanks a lot.
The landing page on the only4sim.git book is in Chinese. Is there any plans to turn that to English?
Yes, that's what I did this early morning.
Yeah.
And and thanks for using that. And you can see there on the left hand, there is a choice, there is a selector. You can select the English word, it's already there, but it's automatically translated by AI with my mapping of the dictionary. And I already noticed some things there, but in general, the content is correct. So,
Amazing.
Yeah.
Thank you.
Thanks a lot.
All right, next up we have Tamagna, who was going to talk about his implementations of Fossil in Nimbus.
Thank you. Hello guys, I'm Tamagna, so I'll be presenting my implementation of Fossil for the Nimbus CL. So, not to bore you guys a bit, I'll be giving a brief introduction to what Fossil is. So basically what Fossil does is censorship resistance. So how do we do it? We have a set of IL committee members. They publish their IL, signed ILs. We aggregate them and then we try to check whether the inclusion, whether the block which is produced satisfy these ILs. So yeah, doing all of these things will give us censorship. Let's say if one of the ILs is giving a transaction from Tornado Cache, then I cannot censor it because we already know that there are 3 builders. So there's a chance that your transactions might be censored. So this helps it up. So going directly into the implementation details. So from the beginning, the parts are how is the inclusion list stored. So there is 2 data structures, the inclusion list and the inclusion list stores. The inclusion list store is something which is shared by the entire, let's say, process, where all of the inclusion store which is coming are validated against and stored. And also the spec helpers, let's say the signature, for verifying the sign inclusion list and stuff, everything that's coming there is from the spec helpers. You can find that in the PR. So yeah, for the engine API, for the Nimbus client, if you don't know, the engine API is located at Web3. So over there, we have changed to the Nimbus to the engine API, which is 3 folds, which is one of them is the get inclusion list v1, the update payload with inclusion lists, and so those have been implemented in the engine API, and then I have plumbed it inside the CL with the EL manager, where I can query either, let's say, one EL or all of the multiple connected ELs in a sequential manner. Yeah, for the networking stuff, there's the spec which says that for the spec I had some help, but he dropped off. So we don't have him here this time. So after that, I took his work and then because he had only implemented the functions for the networking for the validating ELs and for ILs, my bad. And so that's there. Then I have plumbed it inside the actual networking code and getting it to work. So yeah, so that's a brief overview of the implementation and what are the remaining work. For the remaining work, the majority which is remains is testing it out very much. So like for right now, I only have tested it a bit with kurtosis on my local system, but like however the problem is already my mentor Agnish is a bit busy, and also like he wanted to wait on how the forking would be done. Would it be done in Golos or like Walnut? So like with that I just have been working on unstable branch, so like getting it rebased on that branch and then working up top of that. Yeah, other than that, the PRs are open. Like I like to get them reviewed by Tersek or Agnish and then getting them merged. And after, let's say we have a Nimbus branch which has the implementation of Fossil, we'd like to enter the public DevNet which is going on. So yep, that does it. For thanks, I'd like to thank Agnish Ghosh, who was my mentor for this. Like he helped me a lot from setting up, let's say, Kurtosis works, how Kurtosis is running, other things, and like because for my Mac there were a few problems with the Nimbus and stuff, so like he helped me out with that. Other than Josh and Mari, thank you so much for the opportunity to work on this. Yeah, that's it for this project. The next one is also my project, so I'll just say Vineet.
Maybe before we start that one, are there any questions about the fossil? Yeah. Yeah.
Great presentation. Glad to see that we're getting more CL clients implementing Fossil. Just a quick question on the update payload inclusion list engine API. Are you guys going to be updating that to just be included in the new fork choice API in the future for future testing with the new spec changes?
For the spec changes, like we are following whatever, like I think for the engine API, there was something by Jihoon, like there's a API, so like I was following that because I was also not very clear on, let's say, what is how we're doing it. But if it does get included in the spec changes, yeah, that is what we'll be doing.
All right, sounds good. Thank you.
Anyone else? All right. We have Vineet also.
Yeah. Hi guys, it's me again. So, yeah. So this has been more of a passion project for me, and we have been prototyping Puret in Nimbus E1. Yes, Nimbus now has an EL client, and we use that on base for getting a prototype up. So I am Tamagna Chaudhary once again.
Hi guys, this is Vineet. So yeah, I chose Puret, and I was working on log part of Puret. So Puret is basically meta EIP, which involves many EIPs. Okay, and these EIPs are basically categorized in two parts. One is SSD part, and other part is log reforms.
Yeah, thank you so much. What basically we need the gloss over is why do we need Puret? So the problem is data verifiability. As we know, like for right now, how the RPCs works is we cannot have verifying with whether the data we are getting is correct, whether it is complete, whether let's say the big providers, let's say Infura or other people are poisoning us. Like there is no way to know or like purify the data we are getting. So that is why Puret. So like Vinny just said, there are two parts in Puret. There's the SSZ parts and there is the log index changing parts. So for the SSZ parts, I'll start into the details. For the SSZ part, for Puret, we wanted to try, we had the new generation of the SSZ stuff, which is the stable containers with the progressive list and the compatible unions. For this, the first thing that was needed was to get up the SSZ libraries up. For this, Ethan helped a lot. And then after doing, we had a few bugs here and there. So like for figuring those out with the compatible units and getting them up for yeah, so for the why is transactions hard to prove? Because right now, as we know, the EL side all does everything with the RLP plus Patricia tried thing, so like that's not very proof friendly. Like we need a lot of things, we need the neighbors and stuff. So over there, like how already the CL has implemented SSZ, we can do that. And like this has been a contention for a lot of time in the ECD calls. Like even we were present, we wanted to get it included, but like one of the things that always comes up is it's not the time for SSZ. SSZ is not ready. Some clients don't have production SSZ libraries. We don't like the libraries. They say X is written and Y is written. So that's there. Yeah, so like I just said, it's very important to prove, let's say, some parts of the stuff rather than the entire stuff. For them, the SSZ roots are helping. Also, like, let's say, I need to, let's say, prove only this part of the transaction, only the data, so which is coming up. So for these things, this SSZ is pretty helpful. Yeah, so the more important parts of the partial proofs which comes in are the receipts. The receipts already have the logs in them. The logs are very important. Let's say L2s need the logs, you need the call data. Now you want to verify only, let's say, the small part of it. You will need to download everything. Then you need to compute to the root and stuff. So like that's pretty hectic, and like that's also pretty bloated. So like the better result to this would be SSZ, which is what we have already implemented. Yeah, so the final thing with the SSZ transactions, SSZ receipts, and the SSZ withdrawals is leading to an SSZ block, which is something we have been working on. So the entire thing, like we just said, because it's SSZ, to make part proofs of the stuff is pretty easy. Like let's say L2s can part proof the data that they want, the call data, the logs, or like let's say the apps will need some logs. They can only just query those logs and get them. Yeah. So the second part of this was the log reforming, because we already know that there are certain holes in the logs which they exist, and also that the current Bloom filters is a bit outdated. So Vineet will be taking over for that.
Yeah. So the problem with Ethereum logs is, the current Bloom filter is a probabilistic data structure, right? Due to probabilistic nature, what happens is when you query for the logs, you get a lot of block headers in return, and some of them don't contain the log due to the false positive nature. Why the false positive happens is because of the collision. So two addresses can map to the, so Bloom filter is a 256 bytes or 2048-bit data structure where two addresses can map to the same byte, and that results in the false positive. So to reduce that, I implemented log value index that is part of EIP 7745, which is based on SSE-based data structure for logs. So in current scenario, as we discussed, ETH get logs, has to go through a lot of blocks to give it back to the clients, light clients, and that is really time taking and inefficient. And in some cases, smart contracts don't emit proper logs, so it is hard to get proper history. So yeah.
Yeah, thanks for that. Other than that, also the two other logging EIPs we worked on were system logs, where let's say all of these things emitted for the system contract are logged up over here. We have one small issue, which is some part of the tree is the same with the withdrawal trees, but like some way to reconcile that is something we'll be looking forward. Also, the other thing was e-transfer emits a log. Like this has been something that is very important. Like not all e-transfer gets committed, or like to get, let's say, my wallet balance, I'll need to do some off-chain stuff with the indexes or some things. So like rather than that, having something to follow through would be better. So like that is why ETH get logs has been implemented for the Nimbus Pure demo. Yeah, so like this is the field of all of the EIPs which we have covered for the logging improvements. Filter maps, would you like to go again?
Yeah. Can you go to the back slide previously? Yeah. So regarding EIP 7745, it's a two-dimensional log index. It has several changes. One of them is changing existing log types to SSZ types. Why changing to SSZ types is because SSZ types are deterministic, Plus, SSD types have inbuilt capability of Merkleization, right? When we talk about better proofs, we need Merkle proofs in the logs. So SSD provides us plus deterministic serialization, right? And to achieve that, this EIP introduces one log index data structure, which is SSC-based data structure to store logs. And it introduces filter map, which is a sparse map, 2D bitmap with very large size to accommodate all the basically addresses so that they don't have collision. But it's a sparse matrix, so only the bits which are set are stored. Okay. So yeah, let's move on to next thing. Yeah, I just need to clarify things. So yeah, I mean, so log index is like there is a relation. So log index like what log exists. It contains all the logs data. There's filter maps. So filter map is basically a data structure which help to store and search the logs efficiently, because log index is like a sequential data structure, and log index, and filter map is required to fetch logs efficiently and store map them efficiently. And we have log index summary. Log index summary is basically the structure which is replacing the Bloom filter. And log index summary has proofs and several fields which are required for efficient lookup of the logs. So, yeah.
Yep. Thank you so much. So we'll be going a bit into the implementation details now. So yeah, for what we did for the SSZ stuff was like I just said, we needed to get up the SSZ libraries up. After that, the parts were like debugging the SSZ transactions and stuff. So SSZ transaction, SSZ receipts, SSZ withdrawals, and then the SSZ block, which is we have already implemented in the Nimith library. Like how we have gone for it is right now we want to introduce the SSZ into the EL. So like the path we are choosing right now is just to changing the roots. As of now, only the transaction roots and the transaction roots and the receipts roots and the withdrawals roots. These three things we have changed. And also there was an the JSON RPC change which Ethan had implemented with Ethereum.js, so like which we have, which gives us the entire proof for the SSH stuff in the JSON RPC. So yeah, other than this, we had a small try to get some steel tests up, but steel was going through something known as the weld, and like I had to get Nimbus ETH1 running and getting everything done. So like that is something that we'll be looking into afterwards, because right now for the SSH stuff, Nimbus is the only implementation. Like it would have been better to have some other implementation to test upon, or let's say the steel tests to check if the implementation details were right. For the log index and the system logs, we have already implemented the system logs and also the ETH transfer emitter log. These were minor changes, not like those much, and we have also gone through and implemented 2D filters and the filter map data structure inside Nimbus. So like the next steps would be to use these data structures to get better ETH get logs calls, and like let's also do a test on the performance, how the performance increases, because based on the get implementation by results, there has been improvement. So like we'll like to see similar results after the cohort.
So some changes that were made for SSE-based log index. So we migrated the existing log types to SSE types in Nimith package. And for block processing, the flow that is happening is whenever a block is received from peer, the transactions are executed and logs are collected. And then these logs are added to log index summary. And at the end, added to log index, and at the end, log index summary is calculated, which has a lot of Merkle proofs and all. And it is a 256 byte structure, which is replacing the logs Bloom. So yeah, this is how it is. And in the end, log index is being stored in block reference for each block. Plus, it is also stored in VM state. Yeah.
Yeah, okay, so I'll be glancing over the future works that we have remaining. Like I just said, this was a POC work, and so after this, like the thing that we have in mind is this work will lead to a lot of newer things. Like let's say there's like the top on the list are two basic things, which is the SSZ engine API, and let's say we'll try to run SSZ DB instead of the RLP DB for Nimbus, which is I'll be changing the code DB, which stores the blocks and the receipts to have let's say better ETH get logs or this partial proofs running better and like getting let's say benchmarks for the other stuff and like for them. The second thing, which is something that we have been talking about a lot, is the SSZ engine API. For this, we have something in mind. Our team leader Jacek also has some things in mind. Like this is something which needed Pureth up, and like also I needed to implement stuff to understand how it's happening. So like that is something I'll be moving to for the next implementation bunch. Other than that, the other to-dos are a bit more on the side of, let's say, cleaning up. Like, let's say we have the transactions, EIP is changing a lot. Like, there have been people building on top of it. There have been changes to how we are storing the SSZ progressive lists and stuff. So, like, that is something I'll be needing to bump. And let's say we'll also need to freeze it for moving forward. Other than that, yeah, so like the custom DB, as I said, and then testing, like I just said, testing is something which both me and Ethan have very raised. Like we don't have enough test cases, and like we'd like to get a steel test up. Like I'll be doing that in the next part of this project. And for the log index summary, the problem is that it only moves in forward in time. Let's say for one block, I add the bits for the log index, like I cannot move back. So like how will reorgs how will we handle reorgs? Like is there any way to, there are a lot of ways to do this, but like what would be the best way to go ahead for this is something which is an open question, which we'll be researching on for the next part. And also 7745 is a bit complex to implement. This is what both I and Ethan feel. We might try to simplify a lot of things and then push it forward for the ACDEs. Get has been trying to get that included in the latest ACD, which I was there, and there was supposed to be a presentation, but that's for the next one. So yeah, other than that, as Pureth stands for to purify it, we'll need something as a purifier a minimal purifier library, and getting Helios and let's say Nimbus verified proxy, working with them for a demo. And like the very next steps which we'll be doing is we'll be having a testnet app, will be calling wallets, and we'll be calling Helios, Nimbus verified proxy to build on top of Pureth and getting their improvements, the suggestions, what is working, what is not working, and then again go on the board and redesign stuff if needed. And yeah, so like a lot of things remaining, a lot of things done. So like, thank you.
Yeah. I just want to add one point.
Yeah, a bit more remaining. Yeah, so like the end goal for Pureth is to make the RPC data verifiable. There should be no, hey bro, I am trusting this stuff, or not that there is no proofs, there should be no trust assumptions. So yeah, this is the thank you. Yeah, so if you guys had seen, Nimbus had posted a blog post for the light clients in Amsterdam by Ethan. So like over there are a few suggested views of the EIP inclusions. Like for the upcoming, we like to get the new progressive lists and the progressive unions inside. Then that helps our stuff a bit because the SSZ libraries are bumped to the latest spec. Other than that, the things which we are in favor of for H-star is SSZ receipts and SSZ transactions. And Bloom filters is something it's okay or fine, but it would be better to have it done. And some things which we do feel should be done a bit later or in H-star, like there needs to be a time and not exactly Amsterdam, is basically e-transfers. And also, like I just said, 7745, there are a lot of holes in 7745. Like the idea is pretty good, but like it needs a bit more cooking in the oven for it to be better. And for special thanks to Ethan. Ethan is the EIP author. He has been helping us a lot over everything. He has been showing me how to work with Nimbus, because in Nimbus, you can't work in Nimbus without having some Nimjank clustering you up. We found an issue with the Nim compilers and stuff. Other than that, Advaita has been pretty helpful. From the EL side of things, he has been helping us, let's say, introduce the new SSH receipts into the DBs and stuff, and everything has been there. Marsh and Jory always forever. They have been getting this forever, and like my own Advaita and Agnish were EPF4 fellows, so I have not been here without for them. And also Dan from the Steel team has been helping us for the tests, and so that's all. Quite long slides. Thank you so much for attending.
Thanks.
Any questions?
Yeah, sure.
Just a quick question about NIM. How was your experience getting into it? What it was like starting a new language? Like, because you got up to speed very fast. So maybe if you have any tips or
So the thing is, getting up to date with NIMB is very fast, but how Nimbus uses the Nimbus build system was a bit problem, because like I changed the vendors and let's say the NIM cache would get corrupted and like I could not build, and I had tried to do an RMRF. Then it's the dot. Then I understood that it was the .NIM cache which is causing the problems. Other than that, working with the Git submodules and the vendors was quite problematic at first. Also, the SSZ library was also something that was only being, like I could only use it while I'm using the Nimbus build system to link the vendors. Like that is something I also worked on for the, like there's a PR which got merged, which like I can use it as a library right now. Other than that, Nimbus also like, the Nimjank stuff, like while working on there, like it was showing some type inference error. So like this got deducted back, so that because let's say the problem with NIM is if you have an enum with the values and a type with the values, it takes, when it's an optional of type description, the value gets picked up. Like, why is that happening? No one knows. Like, that is a problem with the NIM compiler, and there's been an issue raised for this stuff. Other than that, NIM was pretty fun. Like, the language is pretty fun to write. The language is pretty fun to play with. The performance of the language is pretty good. The only problem is my laptop is a bit old, and building Nimbus takes 7 minutes to 10 minutes. So like that's the only parts which are the problems.
All right, that concludes our morning session with all the CL stuff. So we'll take a break for lunch. And we'll come back around 2 o'clock to move into EL and other items. I'm trying to figure that out.
Okay, hello everyone. Our little lunch. We want to surprise you a bit. We've made some special merchandise, some special edition fellowship things for all of you folks. So yeah, for participating in the fellowship and for coming all the way here, you deserve something great. So little football country of our own team of EPF6. What we made. So we have one for each of you folks. Let's get it to you. So before we start, let's make sure that everyone gets one of these, and as well as the scarves. We have these patches. These are just like EPF patches, not random. There are a bunch of stickers here. Make sure to get the stickers as well. But these are patches, which means that they are on Velcro, and they have also a sticker. You can make a Velcro anywhere. You can put it on your backpack. You can put it on the scarf. And this is a collectible that every person who only participated in this cohort gets. So yeah, some memorable. So please, let's get it to you guys. Yeah.
Come on up.
Come together, come on, like, don't be, need to take it everywhere. Guys, there are two of them, yeah? Yes. Really nice. Yeah. Thank you. Yeah. Yes, there we go, grab one, yeah. Is it, oh. And a patch. Can I get one patch? Yeah, patch. Patch and a scarf. There we go. Follow a scarf and a patch. There we go. There we go. Who's gonna get a one? Scarves. Come on. All the fermenters. Everybody's outside. Come on. Okay. If they were outside, I'm gonna. Okay, so hope you enjoy your scarf. If you come back to Europe or somewhere where it's cold, I'm sure it's gonna be much useful than here. We continue our EPF day after little Christmas presents with proper talks again. So the next up is Ellie. Hope I can welcome you on the stage. Please come join us. And I believe we have the presentation ready. So next up is Ellie speaking about the ephemery testnet. So thank you so much for making it all the way here, and it's yours.
Well, hi everyone. I'm Ellie Anvari, and I'm a software developer now for over 10 years. And for now, I'm a member at 6 Ethereum Protocol Fellowship, just like you. And the project that I worked on was implementation of EIP 6916 and Besu, Hyperledger Besu. So what is EIP 6916? It is, as you might know, it's known as ephemery. It's a testnet. It's a short-lived testnet, which is supposed to recycle every 28 days, almost a month. And this reset functionality gives it the ability to be very small and light. So plenty of these funds and these testnet can help the stakers and developers, so they can avoid the complexity of dealing with a testnet, which is much more heavy and yeah. So this testnet, it changes the chain ID and also the timestamp for at every ephemery cycle, and it discards the old chain data and starts with the new chain data and a completely new database. It disconnects all the old peers and searches for new peers on the network. So when I started this project, users could run an ephemery node with base2 just by running simply this network ephemery command option. But couldn't automatically restart every month. And so for every month, users should manually do the process. And what's the process? It's just you have to delete the old data and provide a new database, like folder for data, and give the path of the folder with this data path command line. And but this process, since it's every 28 days, it can be annoying. It stops the client from running for a while, which might end up with consensus issues, which is not something we want to happen on any network. So we need the implementation of auto restart of this testnet. I implemented it on Besu. So a little bit about this, the architecture of the design. And the Besu is, I primarily designed it the most implementation was inside this Besu command class. But it is it's a class with lots of responsibilities on it. I mean, it has, it's responsible for this, all the configurations of all the networks and Besu that's running. So it's pretty much heavy. So I decided to move the implementation to runner class. The link to both implementation is on the slide. Now more into implementation details. We need to schedule this the restart. It happens through this schedule ephemery restart function inside the runner class, of course. And it obviously schedules the base2 node to rerun every 28 days. It stops the network. It prepares for configurations, and then it starts over the network again. This is the logic that's handled inside this schedule ephemery restart. Also, we have this initial process function inside. It's inside basic command. So it handles all the reinitialization of this ephemery when it restarts. And also it splits the functions and functionalities that we need to run at every cycle. So it's mostly some part of the run function inside the Besu. For every other network, I just tailored it down to ephemery network. So and named it like initial process. Lags are so I did lags that is important, and tests and documentation. I wrote 2 tutorial writes up, one at the beginning of the cohort, which was about how to run ephemery node on Besu, and with its consensus pair Teku. And also at the end of the cohort, I wrote another one about how to make Besu and run a Besu as a boot node. This is the function which I described. So stop the network. This is the stop network function. It just stops services. It clears the old chain data, and also it clears the allocated ports. And prepare for restart. This prepare function. Actually, we need it because I do not like take down the whole Besu node. It's just restarts at one point. I mean, not all of the functions are going to be down. So I needed to somehow force these the state variable inside the Besu plugin context impl class to uninitialize, because we are at the middle of startup of Besu. It's not uninitialized. So I made it through this function restate, and also function reset was needed to make this RacksDB to be reinitialized, because we are going to initialize the database again for the next change. And start ephemery, which does all of things that are going to, we need to run the ephemery again, which is like, it creates a new empty database, new empty folder for ephemery. It's called ephemery chain, and then chain ID, whatever it is at that time, and imports the new chain data inside it. And also it starts peers that we dropped at this stop time, and it searches for new peers. And also it preserves the initial client key that we gave it through the whether the command line or it generated by Besu for first time, and it writes the key into the new folder, this ephemery chain ID folder, which makes it able to become a boot node. Challenges. I think to me the challenge was because this, as I said, it can be happen through manual process. So it wasn't easy to convince the Besu team to consider it the implementation natively inside the code base. But it happened at the end, and I'm happy about it. And so I tried to implement the code in a way to convince them. Also, another thing is that Besu is a old Ethereum client in this ecosystem, so the code base is really mature, and any change to the code base of Besu is, I mean, it comes with a challenge and risks, but it's a good way to grow thick and skin, I guess. So 6 cohort of EPF, how was it? To me, honestly, before this program, I had no idea that I could contribute to Ethereum core, and but I did it, and it's reduced my fears, which I had a lot, and like fears of touching a I don't know production level, which is running already for many years. Client like Base2, and also my mentor was very perfect with the feedbacking me on my work. So reading through, I don't know, my updates and everything. So I never felt lost with him. Yeah. And yeah, again, thank you, Mario and Josh, for for guiding me through the whole program. Also, I thank Justin and Sally from Base2 team, and they really helped me through the progress. They were patient with me, and yeah. Also, thank you guys.
Awesome. Thank you so much, Ellie. And do we have any questions for Ellie before we
yeah, I like the idea and also like the project. My question is like every time it restarted, you need a new like chain ID, right? Although I mean chain ID is not very small, but would that still create some like garbage in the chain ID space? Is there any solution for that? You like a circle, you just
chain ID space, do you mean?
I mean, like now you are like using chain ID is kind of also like a resource, although it's not limited now. But if you created like every month you have a new chain ID,
yes,
and eventually
the
we
chain
will.
ID is calculated through it's just +1.
Yes, yes, but like.
Old chain +1, and your question?
Yeah, if I can add, like it's more of a question on ephemery, and like it's just such a high number that it just keeps iterating, and it's once per month. So we have like 12 new chain IDs a month, and like somebody would have to really like choose this random high number to have a collision, and those that have been in the past are basically unused, right? You cannot, most of the data is not archived, so you cannot, unless somebody spies on it practically, they cannot really, those that have been already used can be reused again. So it's the current one, which is, yeah. Anything else?
Any question?
Yeah. I want to thank Ellie again. Thank you so much for your talk and for all your work. I really want to appreciate your work. I want to highlight Ellie has been working permissionlessly during the last 5 months and also tirelessly working from behind a VPN the whole time in the censored internet of Iran, and it's incredible you've been able to follow us for the whole 5 months. So yeah, thank you so much for making it all the way here. Yeah, awesome. Thanks again. Awesome. Yeah, thank you. And next up, we have another cool talk. This time on a really nice project of research prototyping that's bringing RISC-V transpilation to Aragon to create ZK proofs. Yeah, go for it.
Okay. There we go. Hello. Okay. I don't love talking into microphones, but hopefully I'm doing an okay job. Okay, yeah, so, I'm going to talk about this wonderful title, Aragon RISC-V Executable Proof Sourcing, which is very fancy. But I'll decode what it actually means on the next slide. And yeah, I'm the bird from Discord. Like, it's Movember, that's why I have a beard and people don't recognize me, but I'm the same bird that was in Cannes, just to be clear. Okay, so the project abstract. So currently the mainnet block proving, or like CK proofs for mainnet blocks rely on a full-on EVM implementation, which is then compiled into RISC-V. And then we just do, the people that run this do stateless execution on top of that, and based on that trace, generate CK proof. This project explores a different way of doing this by generating the RISC-V code while executing like a non-RISC-V compiled code by using execution hooks. So while the client executes like normal EVM opcodes, it emits like equivalent RISC-V instruction to encapsulate the same meaning as that opcode. So why do we want to do this? Well, the advantage is that when you don't run the full-on runtime interpreter of the EVM, you should be able to get a much leaner proof or like execution in the actual prover, so that you can get a proof much faster and with less compute resources. Okay, so what have we made? We have created a standalone binary which extends the RPC daemon of Aragon to attach a custom tracer. And we use that tracer to, well, actually, we'll see it on the next slide. That's more clear, I think. And we have a functional POC that can generate proofs on mainnet blocks, but as you will see on a later slide, this needs more validation to make sure that there aren't like edge cases and other bugs. And we are integrated into OpenVM and can use that to generate the Stark proofs. And if you're into like emulators and such, we use Unicorn emulator for the test validation so that we make sure that EVM opcodes emit logical RISC-V opcodes, and this is like tested through CI. Yeah, so this is like the high-level architecture. So we use the lovely EVM engine that Aragon has written and have a tracer on top of that, which gives us access to the StateDB. The output of the tracer goes into like a transpilation module. The transpilation module outputs RISC-V assembly. The OpenVM toolchain then includes this assembly blob and then compiles it into an ELF binary, which OpenVM knows how to execute inside their runtime, and boom, you get a Stark proof out. Yeah, so like, well, one of the hypotheses of this approach was that you would get some linear proofs, or like this would be more optimal than the existing production-ready implementation. But like a big caveat is that this is very much POC, but I think it's still like directional correct with the results we're getting. And yeah, we should also do more comprehensive benchmarking to make sure that this result actually makes sense. As you will see that this is just tested on 2 mainnet blocks, and you might be wondering, why did I only test it on 2 mainnet blocks? Like I even write that it's small sample size, so I obviously know that this result is like incomplete. I ran the results on CPUs and not GPUs because I believe CPUs are commodity hardware, and like GPUs are still like hard to create because AI and stuff. But yeah, if you run some of the existing provers on mainnet blocks, it takes like in some cases up to 12 hours before you get out of proof. And I made like a metric change 1 week before writing the final report, and then there isn't that many hours I'm able to run proofs on, so that's why it's only 2 mainnet blocks. But we do see some good results. So like the average speed up is like 80x, and cycle reductions are not completely one-to-one to number of instructions, but it's good enough, I think, for this. Like you can approximate it to be like closer to 1 instruction. So it's like 160x reduction in the number of instructions that are actually executed inside the CK prover. So yeah, the result is that like our implementation is able to generate proofs in minutes, while existing implementations use many hours. And yeah, the why is that yeah, we don't run a full EVM implementation and have all the overhead from a normal EVM interpreter would have. But that said, we also do know gas tracking, and we don't have a way to do state transition, so you cannot like fully validate blockchain using this. So like big caveat is that this can't be used in production yet, but still an interesting result to see that, well, you can get speed ups by doing this. Yeah, so the future of the project, as I said multiple times, this is very much POC. For it to be useful, or at least useful for chain validation, it needs gas validation and a way to do state transition between the blocks. There might already be a potential use case if people want like tracing proofs for specific transactions. But yeah, long term, like if people, I don't know, choose to embrace this idea, you could maybe like do more decentralized proof generation because you have more consumer hardware aligned approach versus like needing full-on GPU clusters. Although while working on this project, like the number of GPUs you need to like do this in real time has also decreased quite a lot. So maybe like Moore's law will like, I don't know, change that in next year. I don't know. Yeah, so like my personal plans regarding this project is like while it was like very much great experience for me to like learn about CK and I don't know, just approach the EVM from a very different angle and also, yeah, just explore the Aragon code base. It's maybe not the project that, or I expected to align more with the project than I ended up doing. So I think I'll still stick around in this space and like continue protocol-related research, but I'll probably switch to a different project. But if anyone is interested in like picking this up, I'm happy to share my learnings. So yeah, that's basically it. Thank you.
Thank you so much. Awesome, great work there. Any questions? Yeah, we got a bunch of them. Okay.
Oh. Could you share more light to the Aragon to RISC-V transpilation process? Is it like a go to RISC-V or something more low level?
Yeah. Well, okay, so I guess the simplest explanation is that, okay, so when you execute an opcode, you basically can, like you map an instruction, like it's kind of like a hash map where you have like, this is simplified, but this is how you can think about it, that like given you execute a push opcode, well, you have an equivalent opcode in RISC-V, which you can then emulate. So you generate like the assembly on the fly when executing inside actual EVM, like using opcode hooks. So it's not like a full-on recompilation of Aragon, to be clear.
Yeah, thanks for a great presentation, and I like the slides style.
I should also say I'm very the reason I use Beamer is because, you know, Google, I can't trust them, and open source and Richard Stallman. So.
Yeah, it's great. So my question is about the previous question, related to the previous question. So can you guarantee opcode from the EVM and the RISC-V behave equally or equivalently?
Right. Yeah, it's a good question. So I don't know. I'll answer your question, but maybe it's a small detour because I don't know. Originally, while working on this project, like I was like thinking a lot. Okay, what is the correct way of modeling this? Like you kind of want to like at least be able, or like originally I was like, oh, memory opcodes, for instance. I need to like mimic how the EVM is also handling memory opcodes by having this memory section and all of that. And then this thinking kind of evolved on me where I maybe don't necessarily need to like fully have an equivalent mapping, but you kind of want to at least somehow compress the actual behavior of the overall system. So the mapping isn't necessarily like one-to-one. It's like, I don't know, it's a bit based on feelings as well. But I don't know. Yeah, I'm not sure. Was that a sufficient answer?
Yeah, we can talk later.
Yeah, we can talk later. Sorry.
Okay, thank you. With one more, yeah.
I'm also curious about the previous question. So do you have like any research or papers behind it, or is this? I mean, I want to know if this idea, this approach is sound in like security. And, yeah.
Okay. I mean, like, okay, so one maybe different way of thinking about it is that, okay, for instance, there are currently implementations for the like standard approach in both ref and for EPF6, two different Rust implementations. And when they execute like a normal EVM opcode, they would generate a completely different trace because the way they have defined the EVM implementation isn't necessarily one-to-one. Maybe like one implementation is using a hash map for something and the other is using a vector. So the actual code that executes is completely different. And you can maybe like take this idea and just step up, like take it like 10 high levels higher up and just, okay, maybe you don't actually need, I don't know, what's like a good example? I don't know, precompiles. You don't, when you see a EVM precompile call, maybe the system doesn't actually have to execute that, but it at least needs to like output the result of that computation. Maybe you can like oversimplify by just doing like a push of the actual result without like fully computing all that happens inside the precompile. Whether this is sound or not, I guess we can write a paper together to figure out.
Okay, I'd love to hear more. Yeah, thanks.
Okay, thank you. So once again, thank you so much for the talk. Thank you so much for using free and open source software. I really appreciate it. I'm sorry we defaulted to Google there, but yeah, that's awesome. So yeah, thanks again. Great job. Yeah, and we got our next talk, which is about Fossil and the censorship resistance again in Aragon this time. So yeah, Fahil, go for it.
Hey, okay, great. Hi guys, my name is Fahil, and yeah, I implemented Fossil for Aragon, and yeah, just like a brief sort of overview of the EIP and what Fossil is, basically to repeat it again. Yeah, it basically allows or sort of forces the block builders to have certain transactions which were or might have been previously being censored by a lot of centralized authorities, which are currently building blocks. So with Fossil, yeah, it allows you to enforce like transactions in a block, and the block builders need to comply with in order to get their blocks accepted. And yeah, it's for the implementation part in Fossil, it's mainly revolved around three functions, which are on the EL side at least, and the engine API, which we need to implement. And for the fork choice, updated v4, it basically like adds another payload attribute. So whenever your EL is elected to propose a block, you have like inclusionless transactions, which you need to make sure while building block that those transactions are part of your block. And yeah, with new payload v5, we basically just validate that the transactions which are being passed to the new payload v5 method, those transactions are basically included inside the block. And with get inclusion list, V1 is like basically CL requesting for inclusion list, and then basically the EL checks that whatever the transactions are ready for including in the block, and then just passes it to whoever is queuing for. So yeah, in most scenarios it will be the CL, yeah. And yeah, so just to go a little more deeper into how block building works in Aragon, it's they have like an interface, gRPC interface. So Aragon has two EL clients. One is Silkworm, it's C++ implementation, and one is the main Aragon Go implementation. And they have this gRPC interface, so both the clients basically share, and you have this assemble block request, and yeah, basically this is the request which is made when the block building pipeline gets invoked. And yeah, so in our case, when we are going through the fossil route, we need to check like there's no deduplication. So if there are transactions which are duplicated, you need to remove them from the IL list and not reapply them. And yeah, check like yeah, this like a pre-execution filtering that all the transactions are valid. And also you need to store those ILs in state in the case of Aragon. So yeah, that's like the second part of it. You need to validate the inclusion list transactions when basically you need to check like those inclusion list transactions are added inside the block. So that's also part of the part of the spec for the execution client. And yeah. So yeah, I also started. So yeah, the main changes related to Fossil are not too much when it comes to EL, and yeah, mostly are the CL part, and Aragon has like a embedded CL as well. So yeah, once I completed my implementation, I mostly spent most of my time on the CL part of it, which yeah, like Tamagna also talked about mostly the CL changes, so I'm gonna keep it short, but yeah, for most of the time which I spent was mainly on the CL changes, and yeah, that took a lot of time. And yeah, so currently like I have all my CL changes implemented as like in another branch. So yeah, it's like 70% to 80% completed without testing. So yeah, I had to pause just to make sure that the EL implementation is completed and tested. So yeah, I switched, paused working on it for the moment, and yeah, focused on mainly the testing part of it. So yeah, I got, yeah, there are like, when I started testing, like I found a few bugs in the implementation which were pretty evident. So yeah, I ended up fixing them. And yeah, currently, like after a few or deep inside, like when the fork is activated, there are some missed blocks. So there's also another bug which I found out like a week ago. It's related to state. And yeah, I basically need to fix that. So yeah, so that's sort of like the testing part of it. And so yeah, it's like the AC/DC call before DevConnect just had like it's kind of pretty evident now that Fossil won't be part of Amsterdam at the moment. And yeah, it will be shipped in Heka. So yeah, so for the implementers and especially from my side, I basically need to get all the testing done. So in order to make sure that everything is working. And yeah, this like the rebasing thing is also, but it doesn't affect like the EL part over Amsterdam changes. So it's mostly the CL, which will require a lot of changes after the rebase. And yeah, that's like some of the useful links, which like it also contains my PR, the EIP, and like some like specs for execution consensus and the engine API. And yeah, that was it. Yeah, thank you so much.
Yeah, June.
Thanks, Fahil. And maybe I can ask same question to other Fossil guys, but what's the main factor of testing a Fossil? So which metrics do you often see in kurtosis or DORA or something when you're testing Fossil?
Mainly is that, so I can't change the slides, yeah. So basically like in kurtosis, there also like a sort of a tab where you can see the inclusion lists. So for each of the validators, you can see all the inclusion lists, and you can also see like which one of these transactions were included or not included. So that's like, if like there are a lot of missed blocks, then you need to, that's pretty evident there is some bug. But yeah, if there are also like a lot of transactions which are being rejected from another client, that's also like something, you know, there's something wrong.
You mean we can see the inclusion list in the DORA?
In the DORA, yeah.
Ah, okay, I see. Yeah, thanks.
Okay, thank you. Any more questions? Maybe Fossil and Aragon, both ELCL. Okay, thank you so much, Fahil. Yeah,
Thank you,
appreciate the
guys.
presentation. Thank you so much. Great work. Awesome. And yeah, we have one more Fossil talk, this time in Red client, implemented by Subik and Rime, if you know. Oh, sorry, it's Pella. Sorry, I fucked up there. There you go. Now you're the boss. Yeah, I'm sorry. Too many people. Clicker. There you go. Sorry about that, Pella.
Hi, everyone. I'm Pel. Just wanted to start off by saying about a year ago, I watched EPF Cohort 5 in Thailand. Great experience, really inspired me, and it's great to be here today actually presenting at EPF. So without further ado, we're going to go over Fossil again, this time in Reth, and we're going to focus more on the testing side because Phil just went over all that stuff for you guys. So we'll speed through real quick. Quick crash course on Fossil with some pictures to help you guys kind of imagine it a little bit better. And then we'll go through the implementation stuff and then my work doing testing on my implementation and working with other clients. Okay, good. It just sounds a little funny. All right, and then some takeaways from the experience. So real quick, this is kind of what Fossil looks like on the EL. The EL is going to receive this block from the consensus layer, obviously, and a list of inclusion lists. Then it's going to inspect that block and make sure that all the valid transactions are inside that block, with the caveat, if there's not enough room in the block to include some of those transactions, then that's also fine as well. And also, obviously, ignoring any transactions that are no longer valid. Now, why is this important? Today, a lot of proposers are using blocks built by professional builders, and those builders are for-profit companies. They want to keep their profits, so they have to follow the laws and regulations of wherever they're based. So what that really means is that your favorite three-letter agency gets to decide what goes in your homegrown Ethereum blocks. And here's a quick chart, really good visualization from Ethereum censorship picks or something like that. Oh, yeah, right there, censorship picks. Here we can see blocks built by builders and how many of them are censoring transactions. It used to be pretty bad, lawsuits and everything, and it's been spiking up recently, so it still is a real concern, and we don't want to put ourselves where we end up with, over 60% of blocks getting built by builders being censored. So what Fossil is trying to do is make this whole graph green. So getting into the implementation. So coming into the EPF, I did a lot of research on Fossil. I was thinking about maybe doing Aragon, but other fellows decided to take those projects. And I had some experience with Reth, so I looked into a bit more, and the Reth implementation was 5 months stale and still a bit of a work in progress. So I reached out to Jacob, who had been working on it, and he said I could take over, so I decided to do that and get started right away. So looking at Jacob's code, I was able to reuse about 15% of it just because of how stale the branch was, and most of that was just basically the Ethereum spec, but in Rust. So a lot of the actual implementation work I still had to do all myself. And that took about 2 months or so the first half, and also had to fork out some Rust libraries as well to make sure all the primitives were there. So the overall changes, Fahil already went over this, but new payload and fork choice updated. You guys should all know and love them. We're just adding that IL parameter there so that the EL can see those. And then also this new one, get inclusion list, which is going to be building your inclusion list. And the cool thing about Fossil is that the get inclusion list function, the API call, is not spec'd out in the specs on exactly how you build that inclusion list. So it's really up to the client. So hopefully in the future, we'll see some more sophisticated algorithms to find transactions that are getting censored and create a more censorship-resistant Ethereum. And then after I finished the implementation of Reth, Katya, a fellow from last cohort, reached out to me and wanted to help me with the metrics. So me, her, and Jihoon all worked together, came up with some metrics for the EL. These are only 4 of the 5 or 6 that we ended up settling on, but just tracking the overall progress on those DevNets. And it helped us find like some smaller bugs and inconsistencies, but also just a very nice visualization to help, because just looking at the Dora Explorer isn't the best, and going through all the logs can be quite a pain. And then challenges with the actual implementation. The biggest thing was probably just the complexity of Reth. Reth is a very composable client, so jumping into it, especially if you haven't worked on something that composable before, was definitely an issue getting started. But now I feel like I'm in a pretty good place, but it did require a bunch of different libraries I had to manage and keep the versions up, rebasing with Reth all the time because there's lots of open source contributors, so there's like 200 new commits every week or so. So just a lot of slog getting started, but now I'm in a pretty good space where I have it down pretty well. And then also just working in an open source environment and getting used to just relying on mostly myself for everything. Now for testing, once I got done with that implementation, I started testing as soon as I could. Right now, here's all the clients that have some sort of implementation of Fossil. Right now, the only fully up-to-date rebased onto Fusaka are Reth and Lodestar, but Aragon and Geth are very close, and it sounds like Nimbus is even closer as well. And then, so running these DevNets was probably the most important thing for testing, at least for me. I was able to catch a lot of small bugs with serialization and IL validation, just like Fahil said. You find out pretty quickly when the change stops working after block 32. And then also I was able to catch a bug in the CL. Most of the implementations were indexing the ILs incorrectly, so they're essentially passing empty inclusion lists to the CL. So it may look like it was working, but in the end, we were able to fix that, and now we have a fully working DevNet with Reth and Lodestar, and Geth is very close behind. They suffered a bit of a bug when rebasing onto Fusaka, but before we did that, it was working just fine. So hopefully we'll see more, and Aragon and everyone else joining soon, and we can get a full DevNet that's running constantly. And then lastly, I also started working at the end of the cohort on the execution spec tests. So I wrote up about 14 basic ones for now. 9 of them are implemented so far. And this is just a better way that we can test the clients without spinning up a DevNet and all that overhead. And also makes it a lot easier to track all of the client developments. And as you can see, those are all passing right now. And I have plans to just keep working on these and start testing it on other execution layer clients. And then, sorry, I got a little ahead of myself, but continue testing. And then we also, my role and what I want to work on is just helping other clients get up to speed, getting people on DevNet, and making sure we have proof that Fossil works and make it trivial to get it added to the next hard fork. So along with that, shilling Fossil as much as possible and just keeping Reth up to date so that we can get Fossil hopefully an H* if everyone commits to it, but we'll see. And then coming away from this experience, very humbling experience, but at the end, I feel like I've learned a lot more and got involved in Ethereum a lot more than I expected to. Constantly in the Discord, working with other people. It's amazing how much you can get done with people all the way around the world, working on different things. And I definitely feel like I'm in a good spot to keep contributing to Reth and other parts of Ethereum and move Fossil forward. And then with all that said, just quick thank yous. Big thanks to Jihoon, who was like my unofficial mentor for this project, always helping out whenever I ran into an issue or had questions about Fossil. Also, Bo Wagner, who's my independent study advisor back at Boulder, and I met with him pretty regularly, and he helped me stay on track and bounce ideas off of. And then, of course, the one and only Josh and Mario for running the meetings every week, bringing in amazing guests, and getting us all out here to DevCon. Thank you. Any questions?
Awesome. Thank you so much, Bella. Yeah, let's take some questions, folks. Questions on Fossil in red. Anyone? It's a big project. Yeah?
The question is not really about your work, more so about your process, like joining the program as a student who was able to use this as an independent study credit for university.
Yeah, so at least at my school, you can pretty much do it on whatever you want. You just need an advisor to sponsor you and fill out some paperwork. There aren't many other requirements as long as you're not getting paid, like an internship can be, disqualifies you, but I know people have just worked on like a passion project of theirs. So this kind of just fit in the right time frame and allowed me to take less credits this semester so I could focus on my implementation.
Awesome. Yeah, thank you so much. I think that's a great way to combine the studies and work. And yeah, I think that was it. So yeah, thanks again, Pella. And yeah, thank you. And sorry again for confusing the projects there. But now finally, we are getting to Subik and Rime with the block access list implementation in red. So another red project. Please take this one. And I have one more for Rime. So the bowlers, go for it.
So hello everyone, I am Raim and I'm joined with my friend Shaubik. So we have implemented block level access list in Red. So I know most of you are familiar with what exactly block level access list is, but to give a very short overview, it's like block level access list allow you to store changes concerning to that of the transactions or the modification to it presently that of the state, but it extends to that of the pre-execution and the post-execution. And by pre-execution, I mean the system contract changes concerning EIP 2935, 4788, and the post-execution changes would be, sorry for not speaking into the mic, 47, and the post-execution changes would be 7002 and 7251. So yeah, and that would be beneficial in terms of the block building as it would help in terms of parallelization, contributing to a partially stateless Ethereum since we know exactly what slots and the changes will be accessed, courtesy to that of the block level access list. And so what happens more exactly is that when you have a modification concerning that of a balance change or balance increment or transfer, that's get reflected in balance change and non-change, but very particularly during account creations and stuff. And we have the note change and slots modification concerning that of a stores and slot reads like that of their slots and stuff like that. So when we implemented on very firstly, it was like we have to reread a lot of the implementation and go throughout the red code base. As Pele already mentioned, it's quite of a lot when we haven't really have much experience on working on certainly on some level. And yeah, it was I reread a lot of the implementations and also I have to devise some sort of the overview. So to add more of it, I will let Shobhik take on.
Hello, so I'm going to talk about the current status of our project. When we started the project, it looked a lot of different actually. Now it's changed a lot, the specs have changed a couple of times actually. So we have implemented all the core structures that are needed. That is the block access list, it's a list of account changes, and I think there is a discussion about adding the gas used per transaction in it also, that is not confirmed yet. The account changes has the set of changes that are the nonce changes, balance changes, and the storage changes. So we have added that, and that is stored in the Alloy EIP's repo. And after that, we have implemented the actual state reads, so state changes. So initially, we thought that we will inspect the transaction to use the result to construct the block access list, but this has a very huge performance issue, and that's why we directly implemented the change in the REVM, the EVM implementation rate uses. So we just added the state reads and structures in the functions itself that performs the opcodes like a store, a load, and the balance transfer, etc. And we also added the block access list in the block body and the Ketchak 256 has of the RLP encoded block access list in the block header. Then after we are doing this, then the thing of system contracts came into the specs. So we added that, the pre-execution, post-execution, as he has already said. And the engine API changes are for this is Also in new payload version 5 and get payload version 6. Block access list is also added in the execution payload version 4. It is nothing, is same as the execution payload version 3, just added the RLP encoded block access list. We also ran a lot of tests. I think there are currently 16,000 tests in the spec test. So the tests are a bit problematic right now. The hives are not working and the EST team is trying to fix it. I think just today a new version was released, version 1.6.0. So we have tested, all the Amsterdam tests are passing, I think. They have also refilled the test with the other forks, so that are not, I think, exactly correct. We also ran the Cartosys with multiple clients, Wraith, Besu, Nethermind, and Lodestar CL. That was during the version 1.3.0 test. So that was, I think, the result was pretty good. We finalized till 25 epochs. These are the results. There were no missing or orphan blocks till then. So hopefully after the new release, we will run the test again and try to, if there are any bugs, fix that and run the local DevNet again.
Moving on to the next part, after the achievements, I would bring on to the challenges in the project. So what I considered as challenges is that the EIP is quite expansive. If you look into it, it involves modification in lot of level and giving to a transactions or given to a particular block, it's very obvious that we would have a subset of the account which would fall into in a lot of changes, like present in a block or transaction. I personally felt it when working with that of the withdrawals and Coinbase, and we had a discussion of which modifications to look into fast. So but we keep on looking into it and perhaps run a lot of the EST tests which help us to fix our bugs in time. Yeah, and also keeping up with the edge cases, like there are a lot of it. And implementation in terms of that, because the IP is quite evolving on daily basis, we see like some of the new stuffs getting added. As Shobhik mentioned, that the gas use part of it was quite new to us and it's up for involvement, but I think it would help in that of the scheduling the transaction once it's included. So like looking forward to it, whatever it's it, and I guess there will be a breakout tomorrow. After that, we will be much in confirmation whether to include it or not. Yeah, this would be some of the major challenges. And sorry about this. And future scope of BAL. So what would I like to continue is skip rebasing rate and continue with our modifications. The EIP is still an evolving set, but considering the changes which are being included are quite necessary and quite important as for me and as what I believe participate in parallelization, though I believe that it will be taken over by the Wraith team internally, but I would like to have some addition and like have some involvement to it. And we have some endpoint for debugging. We have recently added debug get block access list, but we would love to add few more which would allow us to like get visualizations of what exactly we are missing out while running the DevNet or something. But as of now, the results are good, but still if there is some cases in the future. Perform more testing with the new release. We got a new release of the from the EST sites, and we didn't get opportunity to personally run it. So we would run it and find out if we have some backlogs concerning us, and if this arises, we would fix it. And definitely participate in the local DevNet. As of the implementation, I have seen given there was a transition from using our implementations in REVM to that of Dragon's implementations, and all the modifications we have made so far, I believe our implementation is quite stable, and it will perform well to the given DevNet as well. So with that being said, now Wraith has a block level access list that is used in the BAL DevNet 0. We are much excited because it focuses most of our works. Like, yeah, some good amount of it, though the REVM portion is now Dragons. But yeah, we had some prototype concerning that. Definitely a special thanks to my mentor, Matsy, Dragon, and the entire Wraith team for supporting us this far, and definitely Josh and Mario for guiding us and guiding us through the entire cohort, and definitely the EF team for their constant efforts which help us in testing.
The EST team too, they fixed a lot of bugs in the test when
Yeah.
you mentioned that.
Yes, definitely. And you can find all the resources which are listed here. So yeah, thank you.
No questions on balls in red, folks? It was a great project there, and very important research prototype. So yeah, thank you so much, guys. If there are no thoughts on this, okay. Okay, thank you so much. Yeah, appreciate it. Great teamwork, amazing. Very well, thank you. And we continue with more research-oriented topic with developer Uchi and the ZK VM research. So curious to hear about that. Go for it.
Thank you. Hey guys. All right. Hey guys, it's good to be here. My name is Uche. I funnily go by developer Uche online. So I'll be talking on my research on ZK EVM and something I call hybrid Ethereum. So unfortunately for you, if you're fascinated seeing ZK EVM, I will not be talking about that so much today. So a brief intro of how the EPF went for me. So we all joined the EPF program, and I worked closely with my wonderful mentor, Kev, from the EF. And the major two things I did during this program was looking into some ZK EVM questions and prototyping some research answers to ZK EVM integration questions. And secondly, I worked on something I call the hybrid Ethereum, a POC, for an Ethereum node that can run RIX5 at its execution sandbox rather than running the EVM. So, and it should still also be backward compatible. You should be able to run Solidity smart contracts that have been deployed previously. And for this presentation, I'll be talking more about this hybrid Ethereum. So if you are very interested in ZK EVM research and you want to see some of my ZK EVM research works, you have to scan this QR code. So I have everything logged in a nice way on HackMD. So you could read through. Some are boring, I must warn you. So yeah, they are centered on snackification and yada, yada, yada. So yeah, now into the hybrid framework. So, Vitalik made a post a few months back talking about it would be cool to have the ZK, to have RIX5 as the execution sandbox for Ethereum. And of course, we need to have some data to see how that will play out in the real world. So, and that's one of the major motivation for this program. So to do this, I needed to create two things, something I call cargo hybrid. It's like a framework of some sort where you could write smart contract in Rust and compile to RIX5. And just the way you have Foundry, you could write smart contract in Solidity, compiles to EVM bytecode. And that's what this is doing. And of course, the hybrid node, the node to actually run this RIX5 smart contract. So here's the philosophy as it's kind of a norm here in the blockchain. We are running a very, very sophisticated infrastructure. So any small bad change can be catastrophic going backward. So we have to take things chunk by chunk. So that's kind of the philosophy that is applied also in building this out. And it's just good to have this in mind while this presentation goes further. ZK VM provers today are already working by proving over the implementation of the EVM compiled to RIX5. So if we give smart contract developers access to RIX5 directly, it could bring some long-term efficiency gain to Ethereum. So this is what the hybrid framework is trying to do. So it's going with the Apple-based model, similar to what the team at the Epson. I don't know if I'm pronouncing them well. The Epson EVM team at the EF. I think, yeah, it's that thing that he said. So they made a proposal on how this could be done, more like an advisory proposal on how this could be done, following the Apple's model. So we need to make it smooth and also backward compatible. In Ethereum sense, it means, yes, we can deploy Rust smart contract, C++ smart contract, anything that can compile to RISC-V on the future Ethereum, but we should also be able to support smart contracts that have been deployed before this, maybe hard fork, or anybody who wishes to write smart contract in Solidity still in the future should still be able to do that. And that's what is happening. So this POC stages at a RISC-V backend, and also having some way to run the EVM in some kind of emulated fashion. So to do this, I'm using something I call a mini EVM emulator. It's more like the Revim interpreter. Then I manipulated some stuff to add some syscalls and some of that stuff like that. So the goal of this presentation is to demonstrate a front end for writing EVM smart contracts, Ethereum smart contracts using Rust programming language, demonstrate an EVM, an Ethereum node, which can execute RISC-V based ISA, and also highlights that this node is backward compatible, so you should be able to run a Rust smart contract and an EVM smart contract, also some benchmarks. That's the whole point of doing this. So yeah, first thing first, I have Cargo Hybrid. So it's more like a toolkit for writing smart contract in Rust, something similar to what you have with Anchor on Solana, or something we have Cargo Contract for writing ink-based smart contract for Polkadot, and also the hybrid node. So with hybrid, developers could write high-performance smart contract with modern-based language like Rust, leveraging safety, blah, 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 barring. So yeah, so with Cargo Hybrid, you could do things like Cargo Hybrid new, check, build, so new to build, to bootstrap a new project, check to see your smart contract is compiling fine, deploy to deploy your smart contract on a local node or whatever RPC you're pointing at, and node to run the load, this hybrid node locally. Yep. So this is how to use the CLI. So there's a documentation at the end of the slide, so you could scan if you want to play around with it. So you do Cargo Hybrid new, the name of the project, the template you want to use, whether it's a storage contract or an empty contract or an ERC20 token. So with that, you can bootstrap a smart contract. So next up, you could do Cargo Hybrid check. So this compiles your smart contract to RISC-V and sees that everything works fine. If it doesn't, you see some errors, and you try to fix the errors, your normal everyday life. Yeah, we have Cargo Hybrid build. It compiles the Rust smart contract, but this time around attributes a binary for you to deploy later on. And yep, Cargo Hybrid deploy, in my opinion, this is like one of the most important command line. So this would take those binary, this RISC-V binary, and deploy it on this node, which is most likely running locally. You get an address, and you could pass in some contract-based constructor metadata using the CLI tool still. Yep, so the Cargo Hybrid node command is just used to start up a dev node. You could also use it to start up a production node, but there's no production in this case. It's just a test. So a little bit on how this works. So the Cargo Hybrid node, it works in this fashion. So just imagine the normal REST client. You take out the Revim and put in something else. So Revim is like the emulator for the red client that runs the EVM ISA, if you would call it an ISA. It is an ISA. So if you take that out and replace it with something else that is a RISC-V emulator. And that's what is happening here. So this was all built with the REST SDK. So I managed to escape with about maybe 6,000 lines of code. So it's pretty not so much for a node, thanks to RET. And the hybrid VM is more like running the RIG5 emulator, but having some kind of emulator again, which I call the mini EVM interpreter. So this is what allows you to be able to run EVM smart contract in this node. So if you're trying to run an EVM smart contract, it's going to spin up a RIG5 compiled version of the EVM interpreter, and it's going to run like a system smart contract. So it's more like a smart contract running another smart contract. That's chaotic, kind of, but you see some benchmarks in. So yeah, that's it for that. So let's talk numbers, because that's the whole point for this research. So the baseline is Revim, so just running stuff on the normal implementation of Revim. And so this is some smart contract, a bubble sort smart contract, some hashes. You have to 20 approval transfer. You have to 20 mint, mstore, store, you have to 20 transfer, factorial, Fibonacci, and push. So this is how much time it takes to do this, or this is like a mean time to do this operation. So I'm not expecting you to memorize all this, but just have like an idea of what this is. So on the hybrid VM, this same things, it takes about, for the bubble sort, it takes about 38 seconds to do that, which is about 606 not percent times slower. Just terrible benchmark result. And the many hash, similarly, you could see how slow it is compared to the baseline. So this is running this in RIG5 mode. So in the previous slide, in this mode, this is where the smart contract is written in Solidity, and we run this on an emulator and an emulator. So the RIG5 emulator is the baseline emulator, and the EVM emulator is the second tier emulator, more like a second class system smart contract. So for this is the hybrid VM running in RIG5 mode. So this is when this same logic is being run on just the baseline emulator. So we see that the slowdown is a bit not so slow as before, considerably a little bit more faster. With the many hash, ERC20 transfer, the ERC20 mint, yada, yada, yada. So when you compare these two modes together, you could see that it's not so far-fetched. You could see that when you're running on pure RIG5, and when you're running on the EVM mode, that's emulator and another emulator, I was expecting this should be ridiculously way more slower. But it's not so much the case. There is almost some cases where you have one-to-one, like the factorial. And this kind of gives me at least some good news after having bad news in the last benchmark, that there could be some optimization that can still be done. So I have some docs to play around with it. So some informational docs and some benchmarks and some other further improvements, some things concerning how we could do just-in-time compilation, AOT on this. And yeah, that's it. So big thanks to my wonderful mentor, Kev, and of course, Mario and Josh. And thank you all for listening.
So much, Uchi. Amazing. Yeah, great work. Any questions, any thoughts on the ZKVM research? It's quite a lot, man. I mean, great job there. And yeah, June.
Yeah, just a quick question. Any future plan for a hybrid framework?
Yes. So my whole goal for hybrid framework is to see how much can we push it to have something very optimal. And when we have something I say is optimal, is it enough data for us as a community to be convinced that, yeah, it's good to have a RIX5 sandbox? Because from what we have here with the current data, it's not so much a good idea. If you think about how this will transpire with block production time and the likes. So the first thing I'm going to be doing is going to be regarding just-in-time compilation and AOT. So I'll be trying to squeeze out so much more optimization into this. And Rust as a community, we don't have a wonderful, very, very fast RIX5 62 iMac emulator. We have one that is written about 3 years ago, which is used in this project. And reading through the code, there was so much optimization that can be done. And it's kind of overcomplicated. It was built to run Linux on this. So, and that's not my problem. I needed something lighter. So I would also be working on an emulator to do this much more succinct.
Very well, thank you. Any more thoughts? Anyone? Questions or comments? Okay, I think that's dead. Thank you so much again, Uchi. Appreciate it. Awesome.
Thanks, guys.
Awesome work. Yeah. Amazing. And we continue with the ZKVMs, this time in Lean and Ream clients. Utsav and Dmitris benchmarking the different ZKVMs for the Ream. So, yeah, please keep it. Go ahead.
Hola. Okay. Hi everyone, I am Utsav, and with Dimitris, we'll be presenting our work on benchmarking ZKVMs on Ream CL client. This is a PDF version. Okay. Is this a PDF version or Google Slides version? We had shared another. Okay.
There's Google as well. Google?
Sorry, there are two versions on Google Drive. Okay, a bit more background into why we chose this project and why it's really important. So exactly 1 year ago, Justin Drake introduced the proposal of Beam chain, and it's now called Lean Ethereum. It can be divided into 3 portions: Lean consensus, Lean consensus, Lean execution layer, and the Lean data availability layer. So our work mainly evolved around chain snarkification, and the goal for us is to help Ream contribute towards fully snarkifying the Ethereum consensus layer. Is this coming? Okay. So a bit more about Ream. So Ream is one of the first Lean consensus client to basically implement Justin Drake's proposal. And they started with a minimum beacon chain implementation as well. So, so let us go into more about what our project is. So we had to benchmark ZKVMs inside Lean's consensus layer or beacon consensus layer. We actually need to benchmark the state transition function itself. So the state transition function just takes 3 arguments. The first one is the sign block. It can either be the beacon current block or in future it will be the Lean block. Along with that, it takes the beacon or the Lean state, and an optional parameter which is used by some of the functions is the execution engine itself. And what it does is when all these things are passed to the STF itself, the state is updated, and what actually happens is the slot advances and proposer duties take place, validator duties take place. So what we wanted, so all this happens right now, and every validator running a consensus layer client has to execute this. So what we need to do is execute this part inside a ZKVM itself. The ZKVM executes it, produces a proof of execution, and this proof can then be used by anyone, any validator, and they can, instead of running the function again, they just need to use this proof. They can verify it, and if it's successful, then the block proposer or whoever who actually executed it, they know that it was actually successful. So going back, that helps in chain snarkification. Okay, so our project can be divided into 2 sub-projects. The first one was benchmarking the beacon chain inside a ZKVM, and the next one is benchmarking the Lean chain inside ZKVM. So let's go to the first project. So one of the work I'm most proud of is creating a unified benchmarking platform. So Ream ZKVM benchmarks is a repository, and it contains all these 5 ZKVMs: Pico, RIS0, SP1, Zisk, and Jolt. So anyone could go there, and using a make file, we can orchestrate the guest program, and any of these ZKVMs can be executed, and the state transition function is executed inside those ZKVMs. So what it does is, instead of integrating every ZKVM separately, we have a repository, and in that anyone else could add their own ZKVM as well, and it serves as a single unified benchmark. So there's just one host and multiple guest files for each of these ZKVMs. And so the proving system used by each ZKVM is different, which helps in the diversity in ZKVM. The 6th ZKVM, OpenVM, is fully implemented, but as of now, we were facing some issues with REST dependencies and is not yet integrated in the benchmark itself, and we'll soon be doing that. So the benchmarks can be run into 2 separate modes: execute and prove. Execute mode basically executes the program inside ZKVM, but doesn't actually generate a cryptographic proof of it. So it's more of a trust-based assumption that you are just believing that the proposer executed it inside ZKVM, but there's no proof for that. And similarly, in proof mode, the execution takes place, and it is followed by generation of a cryptographic proof, and that's the reason the proof mode is very, very slow as of now. So if we go a bit deeper into state transition function, it can be divided into 2 sub-functions: process epoch and process block. So what we did was, instead of executing the state transition directly inside ZKVM, which would probably take a lot of time, we benchmarked each of these sub-operations separately, and all of this can be done using the make operation. So if I just want to run attestation, I could just write make run block attestation, specify the ZKVM, and whether we want to do it in prove mode or execute mode. And once it's specified, the make file fetches the test cases which are provided by Ethereum Foundation inside this repo, and the execution of proving takes place. So these are the benchmarks for execution mode. All of the benchmarks are there inside this repo, and this is just one particular test case part of attestation. So as we can see, execution cycles reach almost 1 billion for each of the ZKVMs. However, execution time varies for each of them. And we can also see that execution cycles is actually not proportional to execution time. For instance, RISC-0 almost has 954 million cycles and just executes in 9.6 seconds. On the other hand, Pico has similar cycles, but it takes a lot of time. On the contrary, even though RISC-0 actually executes very fast, we couldn't get proof results for RISC-0. Apparently, it was very slow. However, we did get it for SP1 and OpenVM inside the specs M1 Max, 64 GB RAM. And as we can see, it took SP1 4.5 hours for a single test case. And for OpenVM, it took less than half of that. And we did try it on a different device as well, Ryzen 3400, 32 GB RAM. For RISC-0, we just couldn't do it. And for OpenVM, it took 11.5 hours. Okay, next up is Dimitris, who will be presenting his work on Lean Chain.
Thanks. Okay, so the second part of the project was about redoing the same thing in the Lean Chain, which actually has a different consensus protocol, which is called 3-slot finality. Actually, right now, it's like 3-slot finality mini that's running. And so a slot is divided into 4 segments. So at the beginning, we have the block processing and production. And then we have voting, fast confirmation rule, which helps in fast justification, finalization, and then some other tasks that are running. Basically, for this project, we don't need all these. We basically have to focus at the beginning of the slot where the validator initializes block processing and block generation. And what we did is to add one more task to the validator, which is to generate a proof for the block generation. So the design had to be modular in the sense that every operation that was being carried out by the RIM client should continue untouched, and then we should add one more functionality that does not interfere with the rest of the operations. And so the RIM client is operating using various services. So we created one more service, which is called the Lean Prover service. And so right now, the generation of proof is optional because ZKVMs are not very fast, so the user can choose to activate them or not. So at the beginning of the slot, the validator creates a few messages. Produce block and process block are the usual messages that that are carried out anyways, and then there is another message, generate block proof. And right now, ZKVM will take 100 or 200 slots to produce proof, so it will not happen at the same slot. And then at some other slot much later, once the proof is finished and done, it will be gossiped in the network, and then the rest of the validators will take a few more slots to verify it. Right now, we only support RISC-0, and we proof generation is successful, and right now we generate a proof every 200 slots. And using that, we managed to read up to slot 100 because actually the state is bloating very fast. And then we face concurrent proving, which creates an out-of-memory crash. And verification logic is implemented, but we didn't manage to set up a proper network either in Docker or locally to test, to manage to gossip the proof. So we haven't tested validation, but it's the same as the validation in the beacon chain, so it probably will run. And then also we have not implemented logic that uses these proofs, for example, voting. And there is an open draft PR in the RIM client, which is almost done, with the exception of the gossiping and validation of the proof. And we hope to get some a proper review in the following weeks, hopefully. So what did we learn? Regarding ZKVMs, all of them feature good documentation. There are some differences in the sense that older ones probably have better tooling. So, SP1 and RISC-0 provide very good tooling to measure execution, for example. So you can even track execution cycles in different functions running inside guest, which is not possible with the rest of the ZKVMs. OpenVM has some limited tooling in execution mode, but they have very heavy benchmarking tools when running in proving mode. But at the same time, it's also cumbersome to implement. You have to do a lot of things for yourself, but they're pretty strong. Pico is a new ZKVM with like smaller documentation and good support. And Jolt, very good support, but it requires a lot of memory. And finally, Zisk is also very promising. So what are we planning to do in the future? So as you have seen, we tested only one operation, like we presented a single operation, like at the station. All the other benchmarks can be found in UTSAF's GitHub repo. We would like to expand test coverage even further, especially on the lean chain, to try to understand how ZKVMs behave. And also we were planning to abstract the implementation to not only include RISC-0, but also like the rest of the ZKVMs, like the other 5 that you've seen. And we haven't implemented any optimization yet. For example, GPU acceleration would be a very nice feature to add. And then we have to resolve the issue that we face with gossiping. So either with using Docker or some local environment, we should manage to set it up properly. And also we need to understand what is the main reason behind having the state bloating happening so fast. So all of our work can be found on GitHub, either UTSAF's or mine. Also, we hope to have issues and the pull request reviewed and probably be part of the RIM client in the future. That's wishful thinking, but thank you very much. Thank you, Josh. Thank you, Mario. Unawood was our mentor. We also thank him, and June, thank you, especially at the beginning of the project. Yeah.
You didn't speak so much about it, but it's kind of like a curiosity of mine. So how do you guys plan to do the P2P layer for like moving proofs across across clients? Is it like you think more like a subnet for proofs? Like, could you like shine more
like sharing the proofs across clients, you mean?
Yeah.
Oh, I was not planning to do that. I don't know, like, is there any plan to do? Okay.
Yeah, like research on standardized proof format.
I don't think any of us here are well equipped to answer that question.
I mean, you're welcome to contribute. I mean, that's what the EPF is about, yeah. Yeah, any thoughts on how you think it could be done? Like interoperable proofs between clients and like some standard format for it or something? Would introduce too much overhead maybe, or?
I don't have do you have it?
So right now, inside the repo, we could choose multiple proofs. We have snark proofs and Stark proofs. By default, ZKVMs give Stark proofs. We could then convert them into snark proofs. That would be a prover overhead. But they are really small in size and they can be easily gossiped. And one of the ideas right now in Lean Ethereum is instead of passing the block itself from the EL to the validators, we can convert them into snarks and then pass it. So I guess the idea would be similar to this, but that's more of the lean specs to decide. but that's what I've used.
Okay, cool. Thank you. Awesome. Any more thoughts, questions? It's a big project, a lot of benchmark, a lot of different VMs there. So yeah, thank you so much for tackling all of them, guys. Incredible work. Yeah, thank you. Yeah, and we continue with the lean with Ream Validator by Sherik. So here is your clicker. There you go. I'm sure you're ready.
Hello? Can you guys hear me? Okay. All right, guys, I'm Sharik. Hope you guys are having a great day. And let's get into a continuation of the Ream validator client, on the Ream validator client. So Ream, as we heard, is a lean consensus client. It's a new and upcoming client. Because it's a new upcoming client and a new team, we wanted to train the team on building a beacon chain client so that when a lean client is to be built, everyone has the expertise and experience to build a production grade client. I chose to work on the validator client as it was one of the open projects in the EPF. Prior to getting into it, I had to do some research and understanding. This was my first time working in Ethereum, and one of the good videos was Ethereum Proof of Stake Consensus Explained. A short video, but I took like 10 pages worth of notes out of that 12-minute video because it goes into detail. Not much detail, but it covers all aspects of the Ethereum Proof of Stake Consensus and all validator activities. After that, the EPF Wiki, quintessential resource, everyone knows it here. Validator architecture video on Prism by James was insane. It had everything I needed to go ahead and build this validator client. And then the specs were amazing. Once you see the EPF Wiki videos, the specs become much more readable. So having all this foundation down, we started to delve into building this validator client. So we found that Ream did not support signing, BLS signing yet, and BLS signatures are the forefront of all signing operations and aggregation operations. So I went ahead and implemented BLS signing in the Ream BLS crate. With supporting two backends. One, the BLST backend that was performant and is well maintained, and the next backend was the ZK crypto backend that is optimized for ZK VMs. A similar approach was taken to implement signature aggregation in the Ream BLS crate. Following this, we were ready to build the helper functions that allow us to sign blocks, sign attestations, and so on and so forth. These and a ton of other helper functions are defined in the consensus spec. Each and every hard fork of the consensus spec contains an honest validator spec, which includes types, changes, functions that are essential for validator operations. We ported over 50 of these functions and structs to Rust, and following this, we were ready to build the Beacon API client for the validator. The Beacon API client, every Beacon node exposes a set of API through the Beacon API client. All communication between a validator and a Beacon node, like a standalone validator and a Beacon node, happens through this Beacon API client, through this Beacon API. This includes we can't see that clearly, but this includes publishing a signed block, fetching validators' UTs, publishing an attestation, publishing an aggregation. So we implemented an HTTP client in Rust using the request crate that fulfill all the network operations that a validator needs to fulfill. Following the completion of the Beacon API client, we were ready to build the validator flow. The validator flow, I'm sure most of you are aware of the validator flow, but it starts by fetching duties. If you're a proposer, then you will ask the Beacon node to produce a block. You will sign the block, and then you will submit the block. If you're an attester, you get the duties. you do a couple pre-operations, then you submit the attestation. If you're chosen to be an aggregator, you will aggregate these attestations. You will submit those you'll submit the aggregate, and in a case of a reorg, you will start again from in the same epoch. We were working on these validator flows. A lot of work was done on this, and then we pivoted completely to the lean consensus client. So why did we pivot? Work on the lean spec had started. A PQ DevNet that was announced that was to be held in October, and we had about 1.5 months or 2 months to build this client for the PQ DevNet. 3 teams, Ream, Zeem, and QLean participated in the first PQ DevNet client, PQ DevNet. The purpose of this DevNet, as the last presentation mentioned, was to prove the viability of 3-slot finality and shorter slots, 4-second slots to be precise. Going into this, I increased my knowledge in Lean by going through all the Lean roadmap, which is maintained by the Ream team. And I just narrowed, after some discussion with my mentors, I narrowed the scope of work to implementing the post-quantum cryptography crate, implementing all client metrics that we need to support for the PQ interrupts, and implementing the client spec tests that are generated by the Lean spec. Post-quantum signatures are a pivotal, are an essential part of the Lean chain, and the rise of quantum computers poses a threat to the current state of Ethereum cryptography. Following this, I went ahead and implemented an interface over Benedict Wagner's HashSig crate, which supported signing, key generation, and verification in the Ream client. This crate was then used to sign blocks, sign attestations, and send them over the network. Lean metrics. As the 3 clients interrupt, it was essential to know what was happening within those clients, and metrics helped us get an idea of consensus tracking, such as knowing where the head slot is, finalized slot is, justified slot is, as well as performance metrics, such as how long does each of these clients take to produce, propose a block, produce a block, validate attestation, so on and so forth. So in collaboration with Katia, we standardized a set of metrics that all clients should implement. We implemented them, and we had these beautiful dashboards. The client test vectors for the Lean spec were released shortly after, and although we had ported the specific tests that the spec implemented, it was time to get comprehensive testing involved, and so the Lean, we generated JSON fixtures from the Lean spec. These included an anchored state, an anchored block that the node would anchor to, and then it included steps, a tick, a block, an attestation, and checks, optional checks on each step. I created a system to take these JSON fixtures, run them on the client, and test them. What we found is, this allowed us to debug 2 critical errors. One of them was the validator registry limit. We were following a different one than the spec was, and that was a discrepancy. And there was a minor, it's a major bug, but that a tick calculation had 2 divisions instead of 1 by some variable. These would have been missed if not for such comprehensive testing. As of today, we are passing all the lean spec tests, 24 out of 24, and we have validated correctness before we go into DevNet 1 over the next week. Takeaways. what did I learn? I learned to apply my textbook knowledge of Rust to actually writing some Rust code in a somewhat production grade code base. Thanks to Colby, he makes it really feel like a production grade code base due to his experience with Rust. I learned to write clean and maintainable code. I learned to make good reviewable PRs. I learned a lot about validator architecture and consensus client architecture. And thanks to the EPF, I learned a lot about writing technical documentation. What's next? What's next for me? I plan to contribute full-time on Ream going forward. I plan to learn more about the lean consensus efforts. I've been limited. I haven't delved much into ZK VMs, and there's a lot of interesting stuff going on there. So that's my next stop. This EPF, I concentrated my efforts toward the consensus layer. So I lack a lot of knowledge about the execution layer, which is a gap I aim to fill over the upcoming months. I also, as I met people here, I found they were much more knowledgeable about the Ethereum ecosystem than me. So I need to get up to date on other projects in the ecosystem, including DeFi, L2, dApps, and so on. And I'm on the lookout for opportunities that help me grow my knowledge in Rust and Go, as those are languages I want to excel in. I want to extend my deepest gratitude to Josh and Mario for giving me this wonderful opportunity. I also want to extend my deepest gratitude to Colby and Caden, who have been wonderful mentors, chillest guys, and yeah, I've just learned so much from them. I also want to thank all the fellows that participated with me. It's been a wonderful time working alongside you fine folks and with interesting projects. Thank you guys so much.
Thank you so much, Sharik. Amazing work. Thank you so much. Yeah. Do we have questions for Sharik, folks? Any comments, thoughts, questions? Ream validator client? Yeah.
Don't get that out of me. So I'm not so conversant with the consensus layer.
Yeah.
So I just have one question in that regard. So can you share more insights with what the validator client is?
Okay.
And how's it with the consensus layer?
Yeah. So a validator client is, as Shane mentioned earlier, the driver for the consensus client. It sits alongside a consensus client. I believe you could have multiple validators running with one consensus client, and so the validator client performs all the proof of stake operations, which includes actually proposing the block, signing the block, signing attestations, making attestations, so on and so forth. So a lot of about all the signing operations and communication with other validators happens on the validator client.
So could you speak about the beacon node then? What does the beacon
node what the beacon node does is, so a validator client asks for a block from the consensus client. I believe the consensus client asks the execution layer to get a block. So a consensus, a consensus client, the primary purpose of a consensus client is to maintain consensus across the network, across different nodes. So a P2P layer exists on the consensus client that there's P2P, yeah, so the P2P functions allow all these clients to be in consensus. You could exchange blocks between clients, you could exchange previous state of the network between these clients, and so that's the purpose of a consensus client.
Yeah, anyone else? Any more questions? I have a quick question. I wonder who is the person on the picture there?
Yeah, people say I look much older now. I mean, I see myself as just as young. This was 5 years ago. I've never taken a professional picture since then.
Yeah, it's too professional for it to be.
One day I'm going to replace this, but this is the picture on my GitHub. Hasn't changed since 5 years, but a new picture. We'll take one today. All right.
Looking sharp. Thank you.
Thank you, guys.
Yeah. Okay, awesome. Thank you so much. We have one more talk talking about Yeah, the RIM prototype. Please take it away. Yeah, I hope the slides are coming. Yeah.
Sorry, I just touched.
Just a second.
Okay.
There we go. Okay, one more RIM contributor, and there we go. Yeah.
Yes, another one for RIM. So I think maybe you guys already get tired of the introduction, like what is RIM, but I prepared the slide, I'll continue. So what is RIM, like you guys already heard. It's a Lean consensus client, and Lean consensus is a part of the Lean Ethereum roadmap. So my opinion, it's like a big umbrella for what's going to happen maybe 4 years later or 5 years later. So that's the Lean Ethereum, and it has like 3 pillars: Lean consensus, Lean data, Lean execution. So RIM is an implementation of Lean consensus. So to replacing in the future, it will replace the beacon chain. So it was called, last year it was like branded as Beam chain. So it means it's super fast, like, yeah. So next, what is Lean consensus? So next generation of beacon chain, it will be minimalist, hardened backbone of the Ethereum. So I think some of the key features, it would be sub-second finality. Last year it was 3 seconds or with 3 slots finality. Now it's marketed as sub-second finality. I haven't digged into the details of that. It's post-quantum secure. Actually, the RIM team is working on the PQ DevNet 0. I think it's focusing on one part of it is to use the hash-based signature, like because it's post-quantum secure and enhanced decentralization. Yeah, Lean Ethereum and RIM, the new and shiny stuff, but yeah, my project is not about the shiny part. It's it's about the Beacon API endpoint. Like, I think the reason that the RIM team decided to implement the Beacon chain is that the Lean consensus won't go live, go into mainnet. Maybe at least it takes another 4 to 5 years. So they also want the RIM client to support current Beacon chain. So they already implemented a lot of features before I started this project. But there are still a lot of the Beacon API endpoints open, issues open. So this project is about implement these open issues. So yeah, my motivations is it's related to my previous experience. I joined a lot of boot camps, courses, learning about other blockchains like Cosmos SDK based, Polkadot SDK based, Solana. Like like most of them are just POS chains. They have certain ways, like certain trade-offs to handle things, like single slot finality, that kind of things. But when I started to dig deeper during the Ethereum protocol study group, I found that Ethereum is different. The consensus is different. There are a lot of like really careful trade-offs, smart designs, made it like 100% liveness and 0 downtime. Yeah, Ethereum is not just a blockchain. Ethereum is special compared to other chains. There are so many EVM chains, but they're so different from, Ethereum's different from them because of the consensus layer. So I want to dig deeper into consensus layer. So I picked this project, even it's implementing some old stuff. Yeah. So status of the project, like, oh, sorry, on my first slide, I didn't mention this Jay also worked on this project with me. Like he made significant contributions. So these are the issues we closed with PRs, and we still have like 4 issues with PRs like in review or waiting for review, because the RIM team, they always rebase the code, so to keep the history clean. So sometimes we need to like wait old PRs to be merged to create new PRs. But yeah. So I won't go into the details of these APIs because they are all implemented in all other consensus clients. It would be boring. So I'll share some of my learnings, challenges through the project. So one of the challenges was that so some of the Beacon APIs are relatively easy to implement because their dependencies are fully covered by the consensus spec. And RIM team, they implement most of the consensus specs, like I think converting the code logic from Python to Rust, and yeah. But some of I found that during the project, I found some of the Beacon API nodes actually had a lot of dependencies not covered by the spec. So client teams are free to create their own implementation. So the major one is the sync committee pool related logic. So I had to like went through the implementation of Lighthouse and Grandine. Both of them are Rust implementations. So to reference their implementation of the sync committee pool, how it works, then I fully understand how it works. That I create a version for RIM. The PR is still under review. Yeah, I also have some discoveries. It's like it's unexpected. There is no unified Beacon API test suite. Some of the consensus client team, they implement their own API test. But there's no one like across all CL clients, like the consensus spec test or the execution spec test. So I've been looking for solutions. Then I happened to run into a talk during Ethereum on tour in Hong Kong. Like it was hosted at the Polytechnic University. One of the professors, they demonstrated a project like they're doing fuzzing tests to test all the Beacon API endpoints across different CL implementations. So yeah, I think maybe in the future, this one is not yet released. I think they're working on open source it. Maybe in the future it can be adopted. Like maybe I'll mention it later. So future plans, one of the plan is like related to that discovery. Like maybe the RIM client can adopt that framework, test framework, to test its Beacon APIs. If it's good, maybe it can be pushed to be adopted by other consensus clients. Other things like this. For this project, I tend to like get all my PRs like finished, merged. I continue working after EPF. Other thing is maybe after that I try to discuss with the RIM team leads maybe I'm also interested in some of the lean Ethereum stuff, issues. Yeah. Outside this project, outside RIM, there are two things I'm quite interested at the moment. One is pure ETH from my friend Ethan. Like, yeah, I said I'm going to translate the docs to Chinese, but I haven't started. Sorry, but I'll do it. The other thing is I want to help the Chinese dev communities to get more involved in future EPFs, because I saw so many Indian friends here, right? It's like you guys have huge population and huge base of developers. China actually is the same, but we're shy and we're not. A lot of us are not good at English. Yes, so yeah, I try to help them a bit to close the gap, and maybe next year there will be more Chinese developers in this program. Yeah. Thank you, and thank you the RIM team, my mentor Kobe, and also Unod answered a lot of my questions, and actually 2 of the teammates are here participating in EPF6, June and Sharik. Thank you guys, helped on reviewing some of my PR, and also my good friend Ethan. I'll finish the translation. And all our EPF6 friends and Josh and Mario, thank you for organizing the EPF. Yeah, that's it.
Very well. Thank you so much. Just stay there for a second for questions. Do we have any questions?
Out of curiosity, is there an actual language barrier between devs in China and like the use of English? Like, it's not only translating English to Chinese, but also like their work to English so that the rest of us can read and learn from them?
There's one thing. So at the moment, I can think of is there's one thing we shouldn't learn from them is the 996 culture, working culture. Yes. So about the language barrier, because a lot of us like working in full Chinese environment, we read Chinese tech documents, we read Chinese tech books. A lot of them like discuss the tech, everything just in Chinese. So it just takes long time to adapt. Yeah, I happen to like work in Hong Kong for a long time. For a lot of my colleagues, they only speak English, so that forced me to practice, which is good. Yeah.
Thank you.
Yep.
Yeah, thank you so much. And I mean, like Ethereum it was always like strongly tied to the Chinese dev community. I mean, one of the second DevCon in Shanghai, right? So I always felt like there is a strong connection, so we need to continue working on it. It's great, yeah. Any questions about the project, maybe about the Beacon APIs, RIM? Anyone? Okay. Trent.
Have you shared your frustrations on the testing suite with the EF testing team?
So I actually during ETH Shenzhen I run into like one of the teammate of the Steel team. Like I asked him, he said, "Oh, we're now working on this," but I think that the next step I will like find out how the test suite from the Polytechnic University works, like whether they plan to really open source it, maybe do they want to maybe contribute it to Ethereum, like share it. So yeah, maybe that's the next step. I haven't like shared their frustration yet.
Yeah.
Yes.
Okay, good to hear.
Thank you, guys. Okay, Ethan, one more.
Yeah, from how it seems like these Beacon APIs, you essentially ported them one by one over. I'm wondering, like, if there was any effort by maybe the lean guys to kind of review, like, lessons learned. Where are the pitfalls in those beacon APIs that maybe should be readdressed for lean? Because if we just copy them over, we inherit all the mistakes and repeat everything and don't have lessons. And also, like, why is there a sync committee pool? Didn't they want to get rid of sync committees?
Sorry, about the sync committee pool? And
yeah,
can you
why
repeat
didn't they want to get rid of sync committees?
Trade-off? Sorry.
Okay, I can just answer this question. He was working on the beacon chain end of Lean was building a beacon chain client to get their developers the expertise to build a consensus client. So he was working on the beacon chain. He wasn't working on the Lean chain. The Lean chain does not have an API spec yet. Yeah. So he was purely on the beacon chain.
So my understanding is, so at this moment it's a bit unclear. So maybe the RIM client in the future will support both beacon chain and the Lean chain, but it's unclear. But it will be like it will happen in 3 years later or 4 years later. But
yeah, like because there are no specs for the Lean. The idea is to reuse some of the parts of the stack, and like the API is best to have the same, so you don't break the API, right? I mean that's a golden dev rule. So yeah, one more, okay.
So hi, I mean so many people are working on RIM. So I just want to understand, are there any specifications, or you are just porting existing consensus layer client or writing from scratch?
There's a Lean Ethereum spec in the Lean Ethereum organization on GitHub. You can have a look. I haven't started look at it. Yeah, because I'm working on focusing on the Beacon API part. Like Sharik has something to share.
Work was done on the Beacon chain before work on the Lean spec started. And now the Lean spec has started, all Beacon chain efforts are deprioritized, and all work on Lean consensus followed by the Lean spec and other Lean spec repositories are being done going forward. So if you're interested, like Lean spec, Lean Ethereum, GitHub organization, Lean roadmap would be the first places to go.
Like there's basically overlap. Yeah. Okay. Thank you, guys. I think we can move on. Thank you so much again. Thank you so much. I think you are the record with most questions in this EPF day. So yeah, thank you so much. Okay, we have one more speaker because sadly our penultimate speaker got lost somewhere between Romania and Buenos Aires, so it didn't make it. And we have one last Sato about the LLM tool for security. Go for it.
Thank you, Mario. First of all, thank you everyone to stick around until the very end. I wasn't expecting this many people to be still around. So yeah, and there is a reason why my talk is at the very end, because my project is a bit more about AI and usage of LLMs and a bit less about blockchain as such. So it's a bit more generalizable. So yeah, my name is Satyajit Das, and my mentor's name is Frederick, and yeah, my project's name is Differential LLMing. So in short, what it is about is basically comparing multiple Ethereum clients' implementations of EIPs. Okay, so what's the motivation behind it? So various Ethereum clients implement specs or EIPs in their own ways. Sometimes there might be bugs or edge cases which they might have missed, and those are usually found out during, let's say, DevNets, so much later after they have actually implemented it. So what if we try to do something by using LLMs to make their lives a bit easier? So when they're actually implementing something, if they can get some AI-enabled feedback regarding their implementation of an EIP, then that might be useful for them. So things like spec tests exist, but we should also have other ways to look at implementation status. And because of the rapid growth of LLMs and AI in the past years, it would make sense to see if they can be useful for these sort of cases or not. Also, one more thing, why it is called differential LLMing. So yeah, the idea is to compare between clients and also to see if the clients can learn from each other. So for example, Lighthouse might have implemented the same feature as Prism, but in a different way, which might be a better way than Prism is doing, or vice versa. So if there is an automated way to find this out, that would be great. Okay, so the goal of the project is twofold. So the first step, before we can compare the status of implementation of EIPs across clients, we should be able to know the status of implementation of EIPs in one particular client. So the idea is to first get a proper report of the status of EIP implementation for one client and use multiple reports to simply do the comparison. So you can see the input would be like a EIP or a spec doc, and the output will be twofold, so per client reports and a comparison report. So here is a rough timeline. So initially I had a different approach which I presented in ETHCC. So those of you who were present in the ETHCC, so you might remember. So I had an approach which turned out to be quite more complicated than initially thought of. So during June and August, I was actually starting to implement that approach. Later I realized, okay, there is a much simpler way to implement it. So around the end of August, I talked with my supervisor, and we had a change of approach, which is much simpler. So I spent September and October to actually implement it, and November mostly testing it. So what is the approach? Before I talk about what was my eventual approach, let's talk about the completely naive approach. So what is the most naive approach you can think of? So you take the client code base and you take the EIP doc and dump it completely into LLM and ask the status of it. That is the most naive approach because the code base can be of the order of 10 million tokens. I think Geth is like around 25 million tokens, and LLM context length is only around 200K. So there is no chance that can happen, that can work. The other approach can be that assume that the LLM already knows about the code base and just feed it the EIP and ask whether this EIP is implemented properly or not. That also doesn't work because the LLMs are trained for code bases, but those trainings happened long time ago. And the client code bases, they are updated almost every single day. So these two sort of naive approaches don't work. So in a proper approach, we need the approach to be scalable. We need it to be ideally parallelizable. We want it to work independent of code bases or any arbitrary spec documents. And it should be able to support frequent runs. So what's the key principle of the approach, which I will talk about later? So I'm trying to, my aim was to basically replicate how a human coder actually searches for a particular feature in a code base. So if I simply give you a spec doc, what are you going to do if I ask you to check the implementation status? You'll probably search with some initial keywords, and after those keyword search, you'll find, okay, these are probably the files which look useful. Then you'll start looking for the implementation inside those files. And if you find something interesting, then you might be able to tell, okay, this is actually implemented or not. So this is the key principle I'm trying to implement. So the details of that. So the first step is to actually parse the EIP doc or the spec doc into a set of requirements. So each requirement can be of various kind. It can be a constant, a function, or a field, or RPC. And then, so that's the first step. In the next slide, I will show you how exactly a requirement schema looks like. The second step is to actually produce a set of aliases or keywords, which can be useful for the initial search. So one example is that a requirement might have been defined in the form of a snake case, but it is actually implemented as a camel case. Or it might be implemented as a pluralization. So we need to have enough amount of aliases so that we can actually do a proper search before we are able to use LLMs inside this. So the first step is to actually parse it to requirements, then produce certain variations or aliases of the names. And then we do the search out of those names, out of those aliases. And then finally, we have gathered enough evidences. By evidences, I mean relevant code snippets or the files themselves. So once we have relevant code snippets or the files, then we're in a position to actually use the LLMs. So what we are doing is for each of those requirements, we're feeding these requirement itself and the like the evidences one at a time. And because we're doing it, because the requirements are sort of independent of each other, so the program itself is parallelizable. So, and then once we do for every single requirement, then you can combine all of those to produce one single report for one client. And once we have that report, then you can compare those two reports of multiple clients to actually check the differential among them. So yeah, this is a brief summary of what I just said. So we start with a spec doc, then we convert it into a set of requirements, and this is how a requirement schema looks like. So each requirement has ID, kind, name, aliases, description, which is very important because this is how the LLM will actually know what that requirement actually does, pseudocode, if any, and there's another field called depends on for the cases where various requirements have interdependencies. And then, as I said, we produce aliases and use those aliases to actually do the searching. Then we gain the evidences, and then we feed to LLMs one at a time, and then we produce the report. So I'm going to show two results which are sort of representative of the current status of this project. But before I do that, yeah, let's talk a bit about the setup. So I'm running this for Prism and Lighthouse for Fulu specs. So I basically picked one of those spec docs for Fulu. I'm running Qwen 3 Coder 30 billion parameter large language model, which is running locally on my laptop. I wanted to save some API credits of Ethereum Foundation, so I just decided, okay, it's just better to run it locally as much as I can so that the agentic workflow is optimized before I actually start burning cash through using this API credits. So yeah, I'm using MacBook Pro M4 Max, and it takes around 4 hours for one full spec doc to run. And the comparison code is actually relatively faster because we are simply comparing two files. Okay, so this is the first result I'm going to show. This is what I did here is for a particular function in Prism, I introduced a bug. So as you can see, it should be actually division, but I created a multiplication. And I don't know if you can see this or not. The LLM gives a verdict that it is partially implemented because this does not match the specification of the pseudocode exactly. So what this means in the grand scheme of things is that there are like, 15 different clients now, if you include the Lean Ethereum clients, and every single client follows a spec document. So imagine a scenario where automatically detecting any sort of obvious bugs whenever the clients are implementing any feature. So I think this is at the stage where this actually can be useful to find these obvious bugs. The second result I'm going to show you, that is from a comparison report where it is comparing Prism with Lighthouse. This here claims that, okay, there are minor differences in byte order handling, and it also gives a recommendation of standardize the use of U256 arithmetic. So both of these might look like decent advices, but they are actually not. And it is partly because the LLM itself is not that strong. So it is a 30 billion parameter model. The top models are around like 1 trillion parameter models. So, but this program is at a stage where I can actually start using Anthropic API, for example, so that we can have at least better reports, better comparison reports than this. Okay, so some future work. So I would like to do more testing and some bug fixes. I would like to run with a better LLMs, as I just mentioned. Run on GPU for VLLM. So currently I've been running it on LM Studio on my laptop, and LM Studio only supports one request at a time. So that's why even though my program itself is parallelizable, I can't actually take advantage of that. Whereas if I run it on GPU, then I'm able to run it with something called VLLM, which is an inferencing engine, which can actually parallelize those requests. Then Another thing I would like to do is fine-tune local model with latest programming language version and client code base. So programming language version is also very important. One example I found out is that the program told me that there is a bug in Prism, but that was actually a bug for Go 1.22. But currently the latest version is Go 1.25, I think. So for a previous version, it can be a bug, but for latest version, it may not be a bug. And yeah, the LLM was probably trained a long time ago on 1.22. So this is why it might be very important to fine tune with the latest programming language version. And I would like to modularize the code base a bit so that it is more maintainable and better context management. And the idea is to eventually have some sort of GitHub automation so that the program can run, let's say, weekly for per client code base so that it can generate reports regarding the status of Glamsterdam, for example, in future. So yeah, that was about my main work, but yeah, I'd like to show a little bit of my side work. So I created a spec knowledge graph visualizer where you can easily visualize the entity relationships of various entities for Fulu. I would like to maintain that in the future as well. So yeah, thank you everyone. Thanks Josh and Mario.
Thank you so much, Sato. Do we have any questions for Sato? I see a couple of them. Awesome. Yeah, you're first, so sorry.
Hi, Sato. Nice presentation. So I'm curious about what's your method of training that, for example, when new specs is updated, do you need to make completely new model, or you can retrain that one because of false information?
So there is actually no training involved in the entire cycle, which I mentioned. So the starting point is always a spec document. It looks at it fresh. So it doesn't assume that how it looked like before. So let's say a spec document update happened today, and you run it with the latest one, it will do the entire cycle from scratch. So yeah, there is no actual training involved.
Okay, I understand.
Thanks, Sato, for your great presentation, and I found this can be very, very useful tracking for all those different implementation in other clients. So yeah, it's really great. And I have a question for other approach about the investigating the current implement status. So can we integrate GitHub API for each client team that search for EPF6 and then feed them to LLM that, oh, this is the diff from like Pure DAS or something?
You mean it will find out how exactly Pure DAS was implemented?
Yeah, looking for the GitHub PRs.
Yeah, so the GitHub PR, that is one of the ideas which I didn't end up implementing, but yeah, I mean, it is technically possible to do that, what you're describing. Yeah, that can be useful.
Any more thoughts, questions? Yeah. Okay. Yeah, I wonder, like, working in Prism, right? And now, do you actually use the LLM in your daily work? I wonder maybe like how practical you find it, maybe considering false positives or just generally running it in the GitHub PRs, whether you somehow integrated it?
You mean like writing code or reviewing code?
Because like in the PRs in Prism, for example, whether there is some integration that you tried?
There is an integration which uses LLMs to create PR reviews. Those haven't been as helpful so far. So the underlying language model really matters. So there are only like top 2 or 3 language models which are actually useful for a senior developer. I can imagine. I would imagine those automated PR reviews. Yeah, the corresponding model is not strong enough. So yeah.
Yeah. Okay. There is one more.
I know that a lot of clients have hard time with code reviewing. So how far away are we with getting involved like LLMs in code review?
I'm not sure how many teams are actively working on it. So the the current autopilot code review, that is not as useful. So
Maybe-
my guess is if somebody takes a first principle approach when it comes to code reviews, so there are multiple ways to do or automate code reviews. You just take the patch or the diff of that entire code review and just feed it to an LLM and hope for the best. That is a good start, but that's not useful. That's not that useful because it may miss a lot of context. So the LLM or whoever is actually making the decision, they should actually know the current status of the code base so that it can make such certain form of judgment. So by first principle approach, what I mean is that mimicking a human developer as much as possible, because a senior developer will always do very excellent code review. Why? Because he knows the moving parts, he knows what's the latest changes, he has a historical contextual understanding, and he knows what sort of patterns we implement. And obviously, he knows to look for obvious bugs if things are implemented or not. So all of these actually have to be part of this entire workflow. If we are missing any one of them, it may not be useful. And my guess so far is that the companies which are doing these automated PR reviews, they probably don't have all of these. Otherwise, we wouldn't need human code reviewers currently, but actually we really do. So yeah, we are a bit far from it, I think.
Okay, thank you.
Okay, thank you guys for questions. Thank you so much, Sato, again for your presentation, for the great work. It's a very unique project, so you are the one to close it today. Thank you so much. Yeah.
Thank you.
And yeah, thank you so much, everyone, again for all the amazing presentations today. It's been a long day. It's been a wonderful day. We had 21 presentations today, probably. So many follows, many projects that we've seen today. Thank you so much again for all the wonderful work and all the presentations you prepared and trained and have been working on in the last few days and weeks. I saw that so much effort went to not just the projects, but the presenting itself. So really appreciate it, guys. Now we are at the end of the slot for the presentations. We have one more slot today. In half an hour, we'll have a panel, a small panel, which is mimicking the office hours experience from the online, bringing it finally to the personal space. And before that, let's meet outside for a group photo. So we will have our EPF6 group photo now outside. And for those who didn't get the scarves, please, and the badges, please, for all the mentors, for all the fellows, we have these nice scarves. And also grab some stickers, EPF stickers, forecast, protocol support, and Nimbus stickers that we got over there. And yeah, let's see you outside in a minute. Then we have a little pause up until 5 till the next slot. So see you in 30 minutes and in a minute outside.
Yeah.
Please don't leave me on my own. Don't pack the bags and close the door. Don't drive away alone. I saw your face right in front of me. Your warm smile that I couldn't keep. But was it all a dream? bags and close the door. Don't drive away alone. I saw your face right in front of me. Your warm smile that I couldn't keep. But was it all in a dream? There's so much more that I can get. Don't let me wonder what we could have been. I close my eyes, it's not a dream. I close my eyes, it's not a dream. Close my eyes, it's not a dream. I will miss you, always calling me up, Passive distance, spend most time on my own. I just like being alone. It's no joke, it's my soul, this is my life. I don't do what I'm told, it's no joke, lose control, this is my life. Lose control, it's my soul, this is my life. This is my lose control, it's my soul, this is my life. This is my life. It's my soul. This is my life. It's my soul. This is my life. I will miss you, always calling me up, Passive distance, spend most time on my own. I just like being alone. It's no joke, it's my soul, this is my life. I don't do what I'm told, it's no joke, lose control, this is my life. Lose control, it's my soul, this is my life. This is my lose control, it's my soul, this is my life. This is my life. It's my soul. This is my life. It's my soul. This is my life. It's my soul. This is my life. This is my control. It's my soul. This is my life. This is my life. It's my soul. This is my life. It's my soul. This is my life.
Okay, guys, let's get it on. Let's get a show started. For one last stretch, please take your snacks with you, take your seats. Let's slowly get started here. Oh, no, Rahul is in the center. Oh, do we have Rahul? Where is Rahul? Oh, we don't have Rahul. Sorry. Yeah. Okay, guys, take your seats. We slowly gonna get started for the last stretch of the day. I know it's been a very long day. I know you want it to be over, and after this you will have all the evening, all the time to chat and catch up on everything. But I wanted to give you guys one more opportunity to meet someone and chat with the devs. Kept you the middle seat, man. Go for it. Okay, yeah. Awesome. Yeah, we are right at the time. Perfect. Thank you so much. Very well. Okay, so let's slowly get started. This is our last session of the day, the very end of the EPF day, of the EPF6 cohort, the very end of the cohort. After the 5 months of the work, it all came to this. So yeah, here we are. And I want to welcome our guests. Thank you so much for joining us today. We got Trent from the Protocol Coordination from Ethereum Foundation. We got Ethan from Nimbus team. We got Rahul from the Protocol Prototyping of Ethereum Foundation, and Raul from the networking team, networking research of the Ethereum Foundation. And many guests today, because I try to get as many people as possible for this panel. Because what we do in the EPF is that every week we invite somebody from the client team, somebody from the protocol to join us and talk about their perspective, about Ethereum, their experience. And we do this online every week, and we give opportunity to follows to meet somebody and ask them questions, put them on stage and learn, share their experience. So this time we wanted to do it in person and doing it big time with as many people as possible. So thank you so much for joining us. So I would start with follows to get to know you a bit, to understand your background, where you're coming from. If you can tell us, let's start from the end. Trent, if you don't mind, to tell us about yourself, about your background, where you are coming from, and how you started in Ethereum Core, what brought you to the Ethereum Core. We have very diverse panel, as you can see, people from the different parts of the protocol. So what was your journey?
Sure. So my background is in architecture and design for buildings and furniture. And I did this in university, and then I graduated and did it professionally for a few years. For a number of reasons, I wasn't entirely excited about it as a career path. And around this time, I also found Ethereum on Reddit. And looking back, I was very, very lucky I didn't end up with any of the other projects that were nonsense at the time. I'm not a software developer, and blockchains were still pretty new, and I think people were just excited about them, and I was excited to be excited. And so yeah, I was following along the early days of Ethereum in 2015, 2016. I was involved in the DAO. And just got really sucked into this community, the goals of what people were writing about, the discussions happening on the subreddit. And eventually, after a few years of following along, I decided to stop working in architecture and try to pivot. This took about a year. I went to hackathons. I didn't know anybody. I was too scared to talk to anybody, but I would just kind of wander around as a volunteer. And eventually kind of worked up enough of a network and met people, ended up meeting them in person at these hackathons that I'm volunteering at. After about a year of that, I eventually found full-time work, doing kind of like marketing. And all throughout this, I started showing up to all core dev calls, which I hope some of you have listened into. And this is very early days, so some of these calls were 20 people. It's a very small community at the time. And just continuously showed up to these calls. Again, I'm not a software developer. I'm not a researcher. I focus more on coordination or project management, and consistently built up my awareness of what all core devs was, and eventually found work at a company. And once I left that role, I worked at ETH Global doing hackathons. And then in 2021, I joined the Ethereum Foundation, where I work on coordination around core development, helping to release network upgrades, helping the broader community engage in the governance process. But I spend most of my time working on Protocol Guild, which is a collective funding endowment for about 200 core developers. So I help to manage this organization, solicit funding from the broader community, and then get it in the hands of the individuals who are actually doing this work. So that's the short story of how I got from architecture to here today.
Awesome. Thank you so much. Yeah, Ethan.
Hey, my background is in computer science, like graduated there, ETH Zurich. Crypto, like Bitcoin when it started, I kind of knew about it, but I didn't find it very exciting initially because there was a lot of these kind of things. But I was in like smart home, like embedded C. I did a lot of Bluetooth stuff. And one thing that annoyed me with the Bitcoin wallets was that it was quite annoying to use them. Like you had to scan these QR codes, and it was like back with those janky QR code readers where you had to align it perfectly. So I used the Bluetooth knowledge to make like a prototype where you could like approach with a phone to a cashier, like an iPad, and it would just show up, hey, do you want to pay like 1 BTC for a coffee or something, and you could just slide to pay. And it was like this Bluetooth demo that was really exciting to show to people because that was before we had tap-to-pay credit cards. So I was attending like Bitcoin 2014 conference, showing this demo around, and like Coinbase, BitPay, they were like, wow, can we take videos of this? And then like, they wanted me to make like a short presentation the next day in a coffee break, hey, slide to pay, like this big thing. And then like half a year later, like Apple announced Apple Pay, right? So yeah, like focusing on UX is my background there. I like identifying what annoys me with something, going there and just building it, right? Later when proof of stake was announced, I was like, Ethereum needs something to grow, right? Any chance to scale will be with proof of stake, so I can just put everything in there. Either it goes up or it goes down. It's like, it doesn't matter if I don't put it in there, it just goes down. So I staked it with Bitcoin Swiss. And after like 2 years, it was still like locked. So yeah, I figured, why not look into how to run a client myself and see what's actually the problem? Like, why is this not finished? And then because I'm in embedded, I got like Rocket Pool with like a Raspberry Pi. I set it up, everything. And the only combo that worked back then on the old Raspberry Pi was Nimbus on the CL and Geth on the EL, like on the 8 GB Raspberry Pi 4, pre-merge. And it was quite easy. Like, why do I pay so much commissions to do something that's like doable at home on like $500 hardware? So I downloaded the software, and like after 2 months, I never had to do anything. So I looked up like who is behind, like what software is running here. And then I learned about, NIM is this weird language. And like, I was like looking through the history of the specs, and here is like Dustin copy pasting the Python code to NIM, and like, it looks very similar, interesting. And like identifying some weird things like, that deposits can be front-run, like the very first deposit that you do, like the validator key can just sign another deposit with a different withdrawal credential and then steal your funds that way. So Rocket Pool then fixed that one, like at the same time. They were already aware, but I kind of noticed the same thing. Interesting. So I just started contributing there, and eventually I learned, hey, normally open source is not paid, but here in crypto, there are companies that pay for open source. So I was like, I can just apply here for something that I'm already doing. Like, so yeah, that's how I joined Nimbus as a core developer. And now, like, back to the UX thing, I don't like that, like, our wallets, they talk to RPCs and just blindly trust them. Like, give me my balance, and it's just a number without any signature, without any way to verify. So that's why today when Cloudflare was offline, you could not use your wallets because like we cannot just ask a random server because that's untrusted, right? So my goal now is to provide EIPs like this Purith effort to make it so that the wallet can actually verify that what it gets from the server is correct and complete. So you know, like you have like a secure history and all the transfers in the history are adding up to your balance. That's not the case today, even if you use like a trusted full node and like indexers and so on. There is always like some operation, like a staking reward that's not reflected or like a self-destruct transfer. So just fix all of that. That's my goal now and just push it through. So yeah, that's my story.
Thank you, Ethan. You already answered my next question about. It's all right. It's all right. Yeah, let's. Let's.
Your next question.
You were predicting there. That's pretty good. Yeah, Rahul, please go ahead.
Hi. So I have background in software as well. So I used to do enterprise software, like mostly in finance, and Ethereum and blockchain in general, I think, was being pitched to a lot of enterprise as a fresh angle to finance. But it was always from the marketing side of things. They never talk about the technology because like trying to sell stuff. But I stumbled upon like a course that was being offered as a scholarship by Coinbase that kind of touched upon the technical aspect of it. I remember it like was a week before the Cohort 4 application, and I discovered like the Ethereum Foundation and the EPF effort. I applied for Cohort 4, but it was a very bad application, so that got rejected. Then I took a decision to like take some time off from my work to learn about it. And the more I learned about it, this is not like the fundamentals of what we do today has been laid out like in the 80s. So it's not like something that we are experimenting with. These are like proven technologies or research that has been envisioned for a long time. And a lot of people who I respect kind of work here. So yeah, it took some time out to study like Ethereum in general and the foundation behind it. And applied for Cohort 5, got selected there. Did some work on EVM stuff, and I joined EF January this year.
This one. Can you hear me? Is that on? No. Well, classic. There you go. We have two now. We can be concurrent.
More, yeah.
Yeah. We can get into an argument now between core devs. All right, so my name is Raul. I majored in computer science with artificial intelligence. I guess based on my white hair, you can tell that was a while ago, which also means that artificial intelligence looked very different back then to what it does right now. I didn't end up going into the field. I ended up getting my first job in distributed systems, and that was my passion. The moment I interviewed for that job, I was like, yeah, hell, there's something about getting hundreds of systems within an enterprise setting that was coordinated and choreographed and orchestrated to fulfill like real-time business goals, like, airlines, for example, right? They have hundreds to 200, 300 systems. Many of them are legacy. They speak different protocols. They need to communicate in real time to perform a booking, to do all of the seat reservations, to do check-in, to then track your baggage. And I felt really passionate about that because it felt like I was tapping into the heart of the enterprise, right? Just by like learning all of this. So that was where my career kind of like started in distributed systems. I was a consultant, worked for a large consultancy across many customers, then got into open source. So I ended up becoming an Apache committer and PMC member in 2 projects. That's kind of like where my open source DNA comes from. Ended up joining a company that was behind some of those communities, so got to see how open source gets built behind the scenes and kind of like what is the connection to enterprise, how do sales happen, how do people make money out of open source, right? And there's a whole corporate strategy to do that, and many of them actually, right? I worked for Red Hat amongst those, worked for a company that later got acquired by Red Hat, and at that point I became a freelance consultant. I had I had a ton of customers that I had worked with, and ended up just basically going solo. So that was kind of like, you know, my freedom, my path to freedom. And eventually, after a while, I kind of like got bored of like having really a lot of impact into doing small gigs for a lot of teams and across many verticals, but then really not sticking around to actually see the project to success, right? So I kind of like felt a little bit lonely, and I decided to look for something new. Around that time was when I discovered blockchains, and for me it was kind of like, I saw them as a very elegant progression of my experience in distributed systems, where distributed turns into decentralized, right? So now we're talking about decentralized systems, and it was like like distributed systems, but it introduced a whole plethora of new complexities. So I got very interested in Ethereum, joined a company where I think Trent and I overlapped a little bit. I worked on an Ethereum, on an ETH client from scratch, which later turned into what today is Besu, Hyperledger Besu. And then I joined Protocol Labs after that. So I was at Protocol Labs for 6 years, worked on a lot of things, amongst which is libp2p, around the time that Ethereum was considering a networking stack for the Beacon chain. So I was leading libp2p at that point, and I ended up working very closely with core devs who are still around to actually specify, to experiment with libp2p, to test it, to like basically do the end-to-end. And that was around 2020. I started then focusing on a bunch of other things within Protocol Labs. So Filecoin, the Filecoin virtual machine, launched those things. Then at one point, I decided to, like, I needed to go back to peer-to-peer networking because this is where my heart is. That was around the time that the Ethereum Foundation was looking for a peer-to-peer lead. And surprise, here I am. So that's basically what I do. Feels full circle, coming back to, you know, something that I really, really love working on, and actually seeing that very little has happened in the last 5 years in peer-to-peer networking, and like quickly bootstrapping a team that can kind of like tackle all and chip away at that massive backlog to make massive changes. So that's basically.
Yeah,
nice.
that
Got a
means
nice
that
time.
that was the end of the question. Thank you. Yeah, awesome. Yeah, very well, very well. Thank you so much. We have many people from very different backgrounds here. I appreciate the diversity. I appreciate sharing all of that. And I'm wondering on your Ethereum, it's Windows sounds. Oh my God, out of all things. So on your Ethereum journey, or when you were starting in the protocol in Ethereum community, what is something that you wish you knew at a time that you learned along the way, some lesson or something unexpected that you imagined differently at a time, and you had to take your time, your years to realize that. Yeah, any lesson to share with the fellows? Anything that changed your expectation in something you wish you knew? And anyone who has an idea, feel free to take it.
So something that I wish I knew before was like I should have used the chain more often. I think it's important to be a user first. Like all of what we do today doesn't work quite well. That's frankly the state of things. So if you're a user and you're in a position where you can fix it, that really matters if you use the product or not. So I would say just spin up a test node, use every app that you can find your hands on, and note down things that you can improve, share it with your team. Yeah, so like during the fellowship, I should have done that more often. It's very easy to like, let's say, be focused on any IP or a very small part of the ecosystem, but it's also very important to like look at the bigger picture that most of us probably often miss. Like the users, for the users, it's very apparent, and there's a huge gap there.
Yeah, that's a great point. I mean, there used to be this meme. I forgot the name of the protocol, to be honest. When people are asking core devs the name of this new protocol, like, do you know what is this? Nobody had an idea, right? Like, so detached, basically, from the users, just building in our own corner there. So I think that's very much important to see. Yeah, to see the whole stack. Any other thoughts? Something you wish you knew earlier in your Ethereum career, or something that changed your expectations? Anyone?
Yeah, maybe more minor, but just if you feel out of your depth or uncertain, like even the people who are deeply experienced with this, we're still maintaining and building a new system which hasn't existed before. So there's a lot of learning that's happening in parallel, even though if you are coming from the EPF or just broadly from the community, like I think one of the great things about the Ethereum community is that it, for the most part, it has a lot of humility, and people are generally very gracious with giving their time and understanding that we don't know all the answers, and that's okay, and we're going to work towards a state where we actually do understand, where we do have a better picture of what the trade-offs for some future protocol change can be. But if you're entering from the outside with maybe you don't know a lot of people like I did, right? I had no connections, no relationship, no tech background. It felt very intimidating. And now you guys are on the other side of that. You did the application, you made it all the way through the program. So I hope you feel a little bit more confident. But generally, just I think this is one of the strengths of the community is that you shouldn't be afraid to show up and just be consistently engaged, because there will be people who recognize that and see the value in what you're contributing.
That's lovely, thank you, yeah. Oh.
I want to double down on that. And like when I started, I also noticed that some of the tools, they are just not as perfect as you think that they are. Like when I started, I used like this Beacon Chain Block Explorer because it's like the official one, right? It's like this best one. And it had this bug where like when a block was orphaned, it was not deleted from the view. So like I had this weird mental model where like there could be a finality like in the middle of an epoch because there were like a couple extra entries. And like for a long time, this confused me. But that's not how the protocol works. It's just that the tool is broken. And the same I realized now as a mentor for like EPF, that also this kurtosis tool, it's not perfect. It doesn't work on the first attempt, and it's not your fault. It's okay to like question the tools that are available and to bring up problems and not hesitate asking any questions. Like no question is like stupid or anything. It's just not perfect yet.
So I'm going to triple down on that. I think, yeah, I kind of step on the toes of what I wanted to say. I think core devs are very approachable. We're still figuring everything out, right? So no, and Ethereum is built from, I think it's a very intellectually honest community, and it values the diversity of opinions, and it really takes them into account. And some of the slowness that you might see in Ethereum is precisely because the community is trying to understand the points of view and kind of like all the different directions about critical topics. So there's really this self-organizing community is where you matter, everybody matters, and their point of view matters, right? And kind of like two other things that I would add to that is code and specs over words. Like this is a community that really values, don't tell me what this is and explain it in 1,000 words, just like 100 lines of Python that does the thing that I can play around with is much better, and I'll be able to understand it way better, right? Same with specs. And related to that is like usually you can see people coming in with like concrete opinions and problems. And look, anybody can create an EIP. So if there is a problem and you have a concrete position, right, to solve it, please like don't throw more problems at core devs. Propose solutions as well. It's way easier. It's gonna make it easier to actually navigate the solution space if you take an opinionated stance of how to solve your problem, right? So I think that's another one. And like one final one, you can just do stuff. Just do stuff. Honestly, this is a community that really values that. I've been present in other open source communities where discussions and evolution of the stack like can go on for ages and ages and ages, and at the end of the day, it results in analysis paralysis because nobody knows like what's the right direction. So just do it, show it, like spin up a prototype, spin up a parallel, like thing that is doing something against the chain and visualizing results. Like there's so much that can just be done.
Yeah, Let me double down, let me quadruple down on it. Thank you so much for lovely remarks. For what you said, Raul, I would repeat the famous words of our founder, actually. I mean, the creator of the EPF program, Piper, who was saying that the door to the Ethereum protocol work is comically wide open, right? It's just off the hinges, and you can just walk through and just do stuff. Yeah. So. I hope that that's the lesson that you got from the EPF as well, and thank you so much for sharing all the great advice. The panel, I mean, it was great, and that was more about the past, about your journey and what you learned. And now I would like to look a bit more towards future. I have like a double-sided question about that, and we also heard this already here. Like we are in crisis, and the UX is terrible. Nothing really works as it's supposed to. So there is a lot of stuff to fix. So I'm wondering, like, what are you? Or what makes you excited about Ethereum? What makes you believe in the future? Whether it's something specific or maybe more value aligned? What keeps you going? What you are looking forward to in the future? But on the other side, I'm also wondering what makes you cautious? What maybe makes you worried? What we should be cautious about going forward in our Ethereum journey? Yeah, go ahead. And we have another mic, so feel free to use all of them.
We can only use one at once anyway, so. So what makes me excited is seeing that Ethereum consistently attracts people that are way smarter than me. That would be a problem if I was the smartest guy. So seeing like people who are really, really talented, genuinely nice people, right? You want to have both of these things together. This makes me excited about the future. Well, and not just like smart people, but also younger people. The fact that we can bring in younger people who are also excited about what we're building, get them to understand why we think it's important. Both of these things together are really inspiring about, okay, this project has a path towards the future, and that future looks like it has some positive impact. The part that makes me worried, this is more related to my area of focus, which is on funding and the Ethereum political economy. One of the challenges, I actually didn't know you worked at Red Hat, but one of the things I look at, so I'll ask you some questions after, is previous open source communities. You know, Linux has been around for 30 plus years. They have a much more mature political economy than Ethereum. We're still basically a little baby. But this is going to change over the next 5, 10, 15 years as larger capital entities come and engage with the software production. If Ethereum is a system of software production that has value bound up within it, there's going to be people and entities that come and want to influence or extract value from this system. And this is something that I think about a lot, specifically looking back at Red Hat and how they've engaged with the Linux ecosystem over the years. Their posture changed from very positive sum contributor, and more recently it's a little bit less positive. So this is, again, what I spend a lot of my time thinking about, and this doesn't necessarily mean that the future is going to turn out the exact same way or we'll have the exact same problems, but I hope that we can learn from these other older, larger open source communities and figure out what different kinds of problems might occur in the Ethereum context, and how we can avoid them, or produce resilient systems to avoid these kinds of issues of capture or coercion that would ultimately reduce the characteristics that Ethereum tries to offer as a network or as a system. Yeah.
So what makes us excited, of course, is like the talent here. Like over the past 1 year, it's not an understatement. Like the people who work in the ecosystem are genuinely way more talented than the people I've encountered before. Like the work that Raul is doing. I mean, fundamentals like P2P, you would think that it's like a base layer. You cannot extract more value, but there are people who like question that and then do fundamentally different approaches to the like age-old problem, and then they show like innovation can be done even in the most boring of things to like fundamentally improve how Ethereum functions. I mean, everyone, right? Like people like Josh. Josh, I mean, if there is an app that's launched today, I'm sure Josh has already registered for it and he has an invite code. So, I mean, people are like very, very locked in. So it's very interesting to like work alongside these people. Like whenever I get off a call from a community member, I'm really amazed by like their insight to the conversation that I have with them.
Yeah, +1 to that. And like maybe taking it to like my personal motivation of why I'm here is I see Ethereum as an unstoppable transactional system for humanity. And until we get there, I don't plan to stop, right? And like it starts at the peer-to-peer layer. Obviously, there's like Ethereum is a system that should be able to withstand massive shocks, which are becoming more and more likely over time. And it should be able to operate without interruption, even when those happen. Obviously, there's going to be some degradation. We need to factor that degradation into the system to make it resilient. So building resilient systems is why I'm here, and we have a lot of work to do to get there. And in things that worry me is generally potential capture as Ethereum becomes more and more popular and it grows more veins into the financial system with specific agents going to pursue those opportunities, the influence, I think the vicinity and of the low distance to capital and like the ability to raise capital fundamentally more than like what actually can power core development, right, which is what Trent is working on, can outweigh, and can like create a misbalance there of where decision making happens, and not necessarily decision making, but actually the values that the system encodes in its decision making, right? So I think we can see we're over time gonna be seeing more and more influences coming from, those neighborhoods of, where money is made, and attempts to shape the protocol in specific ways. So I'm kind of worried about potential capture in that direction. And obviously nobody has the ground truth in the sense that, at the end of the day, Ethereum should be viewed. One thing that we haven't done enough is viewing Ethereum as a product, right? From a product perspective. So from that perspective, like my other side also says, well, that is genuine product market fit. So therefore you should listen to your users, right? So how do we factor in like short-term, drive of like, for those gains in specific domains, and at the same time, like continue pointing the system towards the long-term vision, which is, I think, a little bit more connected to what I described before, right? This resilient transactional fabric for humanity, right? So that's kind of like my one of the things that I've been thinking about these days as a risk.
For me, like excitement about Ethereum is like just how flexible it is. Like everything is like building on top of it. And that's a huge opportunity. Like everything that we can do is very impactful on this global chain. It's also something that cannot be built anymore. Like if we would start today, I don't think we could make Ethereum successful like in the political landscape that we are in. So it existing today is a huge opportunity. And yeah, also for the capture thing, the EF itself also plays a huge role. Like they are very dominant in funding the teams next to Protocol Guild, of course. But that also means that it's sometimes difficult to maybe not share the opinion of the EF when it comes to certain topics. Like we had this huge debate on EPBS versus delayed execution for Glamsterdam, where like the client teams wanted one thing and the EF preferred the other thing. So yeah, I mean, right now it's still working, but like it could become a risk, like especially as we are accelerating the forks and taking more risk there, shortening processes and so on.
Yeah. And to add to that, how do we maintain this consensus process as more and more people and entities show up? Because, you know, there's 200 to 300 people that are engaged in core development. I imagine this will increase over time. And the question is, how do we manage this complexity of surfacing different priorities? What's the prioritization process? It's not going to get easier. So, yeah.
Yeah, should have asked it the other way around, because now we ended up on a bit negative note, but many things to be excited about. I really appreciate all of you sharing your values, your what keeps you going, guys. And also, I hope that every individual contributor can take this to the heart, what to be cautious about. So yeah, thank you so much for all of that. And yeah, I mean, the group of core developers growing. We have many fresh ones here, hopefully. And I would like to, we are now in the second half of the panel, so I would like to open it to the audience to bring your own questions. Don't let me use this the whole time. We have this very four diverse, talented, important Ethereum contributors. So questions. Don't be shy. Officers, raise your hands as always, right? Josh was first. I'm sorry, man. It's closer, but.
You guys talk a lot about like the ability to just do things. What kind of advice would you give to young people who are interested in core contributions who maybe don't have the freedom or the ability to just take a month or two or a year to just do things, and they actually need to make money to survive?
Side projects, side quests. Like this is, man, I get really excited when I see what people do on weekends. And just posted it, like people post about it on X, and it's not like I'm not even talking about Ethereum these days, right? I'm talking about anything. Like you just see new, like I don't know, like indie projects showing up the whole time, and these are kind of like side quests. People obviously have a life as well, so it's not like you can dedicate, you know, all your downtime to building stuff. But especially if you're young and you really are, you know, really invigorated by all of this, you know, spend some time and outside, like when you have some downtime, instead of like going on YouTube or Netflix or whatever, just spend time reading papers. I know it sounds like, I think this is the right thing for this audience here, but it's not going to be a popular comment for the internet. But like, I think we generally enjoy doing this, reading papers, like playing around with ideas in our minds, seeing, like looking at forums, seeing like picking up on like small little things that might be useful, maybe like a small visualization of like, I don't know, like execution times of like a specific opcode under specific conditions that, you know, as part of an EIP. I don't know, I'm just making things up, right? And then like doing a parallel simulation of like how a different, and then pushing that and having a real-time view with a website that visualizes like what's going on. Like, you know, one good example is Tony. I always look at Tony, like Rahul's team lead, as kind of like somebody that just builds sites for that really like illustrate, you know, key ideas that he wants to bring to the protocol. And they're like small sites and they're easy to create. And we need a lot more of this because protocol work is deep. Like it's hard to explain with words and specs. It's way easier to visualize sometimes, right? So I would just say, just do small things and push it online, and people will find it.
Any other thoughts on the question, maybe? I would just add to this, like when you mentioned the visualization specifically, I imagine Protolambda, how it just shows up in Discord with these crazy beacon chain visualizations. I'm not sure if you remember those, which is like whole page to zoom in. Yeah. Okay, we had another question from Vukasin. If there are not more thoughts, yeah.
Yeah, I have a question for the architect. So, what is the hardest part in your management? Is it like government process or what? Where do you need to put the most effort to make everything work and to make greatest improvement in Ethereum?
Well, to be clear, I'm not the only one doing this. So that's it's made easy by a lot of people doing the different parts of it that I'm not able to focus on. So having other people around helps a lot. Yeah, it's certainly, Ethereum would not be governed if any single person were in charge of all core devs or, coordinating all these many, many teams. Can you say the second part of the question again?
Where you need to put the most effort to make the best improvement. So have you the hardest area of your work there and your people, not just you?
Sure, yeah. So for me personally, the area that I work in, the hardest part is, well, I'm going to go actually contradict what I just said. There are people that work on the governance of Ethereum, but there are fewer people that think about how Ethereum is situated in the broader context of political economies, open source, how it interacts with capital or well-resourced entities. And I sometimes wish that there were more people thinking about it, or I knew the exact right academics to talk to. So it does take a lot of time to find which threads to pull on. I think I'm getting better at it, but one of these things is just, we have a ton of people that work on the technical side of the Ethereum protocol. And sometimes it's interesting to think about it through the humanities side or the political, social side, because this is a huge part of what we're building, right? There's a community is a people who have a shared set of values and they're building towards this goal. And you can't understand a community just through a technical lens. You have to understand it through the political and social as well. So I sometimes wish that I knew exactly which direction to go and which people to speak with, but it's more trial and error sometimes.
I mean, we had the same thing with the language discussion before with Chinese and Hindu and English, right? When Danny Ryan went on stage yesterday, he described exactly this problem for approaching institutions, like that real-world assets to them are just assets, right? Like, it's a different lingo, different language, and different people, different processes, how you have to approach something like this.
Very well. Thank you, guys. Thank you to the architect. Do we have any more thoughts? Yeah.
So we discussed ecosystem. We discussed opportunities, risk. Now, following up on Josh's question, say a person has found the time. They in this room, everyone has contributed to a project. Some of them have completed their project. Some of them are going to complete the project. So from all of you, on top of your mind, first thing, what's a call for action in your domain that you're like, okay, this is your next project for all of you, for some of you that are interested in that?
As in, you want like project suggestions if you were to, like, if that we would, a wish list?
Like, this is the problem in Ethereum that lingers on my head in my area of, and this is what I would personally work on given infinite resources, and now I want you guys to share the same.
Okay. So one thing that I personally in peer-to-peer that I've been thinking about recently is how do we solve the validator privacy problem? And of course, like Nimbus has done like a bunch of work in the past, and I think we need to revisit some of those ideas and really start making strides in that direction. So thinking in terms of mixnets, for example, embedded, like what would it look like if we had an embedded mixnet within the peer-to-peer layer in Ethereum, and how do we balance that with the need to go faster, with faster slots? Because of course having a mixnet is gonna add latency because it adds hops. You also have the problem of, well, how do you validate that you're not propagating garbage, right? So that's another thing. It connects with like some of the primitives that we're working on around, together with a crypto team, around proof of validator. So is there a succinct proof that we can build such that a node can prove that is running a validator without disclosing which or any quality about it? Like that has another set of challenges as well, right? And can we use that kind of proof to then resolve the garbage problem, or is there like some homomorphic, thing that we can do that would help us validate along hops that what's being sent is a genuine attestation, right? Or signed by a validator? I don't know. Like, these are some of the things that right now, this is, for me, work that we need to start today to work on and to have prototypes so that we can ship potentially next year or the year after. Like, we can ship something, an improvement in that direction. It's not going to be like a massive, like, I don't predict that next year we'll be having a full solution, but at least we can make improvements, right? And this is work that of course, my team is currently very focused on DAS, on pure DAS, because it's very network intensive. We're focused on improving propagation on many levels and specialized broadcast protocols and things like that. So we don't really, because these are like very immediate. So I just like, and then we have this other set of things that I'm describing that are like long-term thinking. Everybody's aligned towards that, but they never become a priority. So I think we need to like plant the seeds now and start parallel tracks that are exploring all these directions so that within a year from now, we actually have some shape of a solution.
That perfectly answers.
Okay, yeah.
Yeah, thanks. I want to follow in your previous answer, actually, since you are working on DAS and pure DAS, and I'm also like just giving my thesis in DAS. So I'm wondering now, from your point of view, what's like biggest challenge of the DAS now, and also what's like barrier now?
So pure DAS, the version of pure DAS that we're shipping is actually pretty bandwidth inefficient right now. So with the protocol and the architecture that has been defined, there's a lot that we can do at the network level that does not require a fork, which is the nice thing about this, that I think is gonna bring blob limits as we ship these things, even beyond what we initially predicted for pure DAS, which was 72 as a limit. I think we can push it to 128 potentially, or even further. So two concrete things are cell level reconciliation on gossips as gossips of partial messages. So that's, we currently propagate. Should I go into like detail or sorry, I don't know if like you want it high level or, well, I'll just keep it high level and then you can find me. So I think like these are network optimizations that we can do on both the CL and the EL side, and both of them have already been specified, and both of them are, one of them is like nearing interop right now between two implementations, and the other one is being prototyped.
Yeah.
So I want to add to that. So Ethereum, I mean, doesn't exist in an abstract sense, right? It builds on like some of the existing stack. It builds on top of the hardware that we have on networks. So oftentimes we have to find, like, for example, gas pricing has been a big like upgrade that everyone's been waiting for, and there's an effort to get pricing more fair to what the hardware is currently in Amsterdam. But we need more numbers there. So the benchmarking effort there could use a lot more help. So anything that Ethereum relies upon, the stack below it, can be optimized. So if you know, like pick anything below it, the networking, hardware, benchmarking, anything, you could just really benchmark it, you'd often find whatever has been done like 3 or 4 years ago, and you'll find ways to optimize it, and then you can surface that information to the community, and then maybe propose an EIP.
Yeah, okay, thank you guys.
Adding to what Rahul said, sorry. Also look at, I think, DFI and still PFI EIPs as a potential, what can I do that is small here that can prove this EIP in practice? And what were the challenges when it got DFI'd that like pushed it back? Was it because people didn't have enough data, and how can I contribute to that, right? And I think those things can be short projects that can have outsized impact.
Yeah, please look at forecast, long list of all the PFI, DFI'd, SFI'd EIPs for all the forks. You can use that as a resource, and you can grab a forecast sticker as well here. Anyway, any hands up, any more questions? Anyone? take the opportunity to talk to the whole panel. Yeah.
So yeah, I was thinking like one of my biggest worries about Ethereum is also like getting captured by bigger capital as it moves towards mainstream. I was just having these questions in mind that I cannot answer basically. So for example, like big corporations would attack politicians by lobbying and these other stuff, like techniques that are very well known and used over the past. I don't know how much like Ethereum is ready to do so if it reaches mainstream. I was thinking, for example, I had to buy some ETH, and then I went through KYC through some exchange. For example, we say that we want some like a universal transaction system that goes beyond borders. But if I have to go through KYC, maybe a government can restrict my access to this, or like it can become, I don't know, illegal for some sense. And I don't have good or quick answers to these kind of situations. And there seem to be plenty. And another thing is mainstream media or other things that could really portray us in a particular way. And Ethereum is something more like a distributed system, and who takes responsibility, who gives an answer, and all of these kind of like technical and legal questions. What do you think about it? Are there people working on these solutions?
I mean, it was like two questions, right? One is KYC specific, and the other one is like how to work like in a regulated environment. Regarding KYC, we have just seen like the Aztec system, where you need to provide like a passport to participate in the token sale. So you have like this zero knowledge app on your phone to scan your passport and locally compute and prove that you are not a sanctioned person. But it also includes like some country checks, like proof that you are not a citizen of these 4 regions, right? And proof that you are over 18. And the risk with these tools is, as perfectly private as they are, is that it's a tool that makes an ID check more easy to use, and that also makes it so that it proliferates more. So these, like controlling access, like trying to not use this everywhere, trying to slow down a little bit, just so we don't have like this on every second website, maybe an option. It's a better tool like when it's for something that already needs KYC. Like certain things need a KYC, then of course the private option is better. But as soon as we start adding more passport checks everywhere, that's a risk, right? The other question about the regulated environment, there is actually like Canton Network, which is like a private blockchain by all the institutions, all the banks and so on, like 600 banks. And they have like these features. They have like so that you can only send to someone if they pre-approve that you're allowed to send to them, or like that you can reject a transfer that you did not authorize and so on. So maybe that's also another way where like the institutions build their own thing to transact between themselves, where they are in this environment. And then we have Ethereum like on a publicly accessible chain where we are more like free to transact however we want.
Yeah, I can respond, but it's not going to be very satisfactory. So in the 90s, I think it was in the 90s, when the internet was first really coming into the cultural forefront as like a consumer interface, there were people writing about, you know, the massive impact that it's going to have, and I'm forgetting the exact name of it, and Anna could maybe fill in the gaps, but it was this manifesto about how the internet is this new world. It's this new, not a new nation, but it's independent from...
Declaration of Independence of Cyberspace.
There we go.
John Perry Barlow. Yeah.
Yes, John Perry Barlow. And it's this idea of like, you know, we have this independent, sovereign space. We don't need nation states. We don't need, you know, the kludgy techniques of the past 200 years. And what we unfortunately found out was this is a pretty naive framing. And you know, through the past 20 years, from the early 2000s through the 2010s, the state is very much interested in influencing the internet. And just because we believe we're this sovereign world separate is very much not the case. And this is still going to be the case for Ethereum, right? We're not designing this system in isolation. It doesn't exist in a pure world separate from its existing context that it's emerging from. It's, in fact, directly shaped by the existing nation states, the existing power structures that are there. And to some degree, we're never going to be able to escape that. We can reduce the worst externalities. We can try to design it to be censorship resistant, trustless, decentralized, and maximize these properties that make these systems useful, but you're never going to be able to completely dissociate from the existing power structures in, I think, the way that myself included, approached this world maybe a bit naively or romantically. So yeah, it's always going to be there. You know, we saw this with Tornado Cash. The US government didn't directly intervene on the contract layer. It intervened in its own domain, which is the world of sanctions and the legal threat. And you know, that's still unresolved. It doesn't have to necessarily change the protocol, but there are other ways that existing entities and power structures can shape these protocols. So unfortunately, we just have to figure out ways to deal with it. And like I said, maximize the properties that make Ethereum special to provide guarantees to users.
Yeah, just to add to that, I think every touch point where crypto blockchains interconnect with the real world and the existing systems is one regulatory point, right? Because those systems are regulated, and therefore any new overlay on top of those or any interconnection is a point of vulnerability in this sense. So I was kind of like mentally doing the thought experiment of, okay, so imagine you did not use exchanges that were regulated, you did not use like real world assets that end up being encapsulations of like things that are highly regulated anyway. Like imagine you want to be completely self-sovereign, right? You can still have apps and systems and websites and everything that help you transact on a peer-to-peer level and to discover other peers that would be willing to participate in that like ad hoc system. But then the problem becomes, well, the distribution, right, of that. So if you have an app store, right, then, well, the app can be taken down by a government. So what are you relegated to? Well, maybe a website. Now you can have a PWA, for example, like Peanut is a PWA, right, and it works really well. You can have that, but then the domain could be blocked. And if the domain is blocked, then you have it's harder to access. And then you can, like if the domain is blocked, well, then maybe you can connect through a VPN or like you can do something else, but maybe VPNs are blocked as well. And now it becomes way more severe, right? Because to get to block a tiny specific set of use cases, you end up blocking an entire like connectivity layer, right? Or like you end up blocking, you end up in a like deep censorship, like, you know, state censorship regime where you're having to do deep packet inspection and things like that. And I think like probably, obviously there are nations that do this. Getting to that point is pretty extreme for most of the world. I think we would like, if the world is willing to go there, we'll be having like bigger problems, right? Not just like, it wouldn't be confined to the crypto space and the inability to like access crypto rails, right? So I don't know, like I have a view where there's always things that you can do and always, one reason or another, if you're willing to transact peer-to-peer, they end up going down to the connectivity layer. And this is networking. Maybe like I have a very networking-centric view, but of course there are things that you can do. There's technologies that you can use to like mask traffic in specific ways that are, you know, gonna enable you to continue conducting these flows and so on. But yeah, that was like adding some thoughts. I thought I was doing this experiment at the back of my head, and it gets rougher and rougher every time. So, and on both sides, it gets rougher for the user as well, right? Because now, like, if you ever get to this reality, you're still a niche. Like you don't enjoy widespread distribution, right? So any widespread distribution is sadly, as Trent said, is going to be subject to, to government regulation in some way, I think.
I mean, I would add to that like the asymmetry also, or like it also becomes harder for the government if you are willing to go that far. Once you are using Tor, maybe if they do deep inspection, if they deploy a bunch of stuff, they are able to somehow track you down. But the cost of tracking you down versus cost of just running the Tor is so asymmetric, right? And I don't want to spend time talking about it, but I try to implement this. I live without banks. I don't do any KYC. I use only free open source software. I try to live on DeFi instead of any bank centralized KYC mechanism. So ETH Culture Day, Ethereum Culture Day on Thursday. Come to listen to me about that, but it's not the topic of today. Okay, I'll give you guys one more question. I'll give you guys a few seconds to think about a question for the panel. One last question in the EPF cohort 6. And take a minute to think about it, because before we finish, I want to make the panel a bit cooler. I'll share it with you guys some swag. There we go. Thank you. And we got these Argentinian fellowship scarves. So we are now that's a pretty cool panel right there. Join you. Awesome. Looking sharp. Yeah. I wanted to share. So thank you so much for joining us today. I wanted to at least somehow pay back your time here with some very special swag. And with that, is there any last thoughts? Any thing that you would like to ask to finish the panel? Anyone, or you will leave it up to me again? Okay. June, come.
I would like to ask Rahul, so you're one of the most successful fellow at previous EPF, and I saw a fancy website you built after EPF, so could you share your post-EPF experience, or could you give me some advices as we are all wrapping our EPF this cohort?
One thing is, I think, it's very important to do work in public. We are a very small community, and we thrive off from knowledge from each other. So one of the goal for EPF was to get you to write technical content, and it's important that you continue doing that. Whatever you do, it doesn't matter what you work on, as long as you build in public and keep doing it for like 2-3 months. People will eventually find you.
Okay, I would maybe extend the question for any last thoughts, last advice for the fellows now released into the wild of the protocol development. Anyone? Okay, we can wrap it up here. Thank you so much again. Appreciate. Yeah, you have a. Okay.
I want to end this on a lighter note and connect us a little. We are here for the next 3 more days. There's DevConnect. Any events that you guys suggest us? You guys gotta go to this.
The Culture Day. That's the first one that comes to mind.
For me, it's the ETH Client Summit, if you are into core devs.
Yeah, I was going to say that one.
They're both on Thursday, though.
I think that and ETH Proofs on Saturday is going to be super, super interesting.
There's also tomorrow the ACK Day with Vitalik, which is like what's beyond Ethereum in a decentralization. Yeah.
There's also a little, I think it hasn't been found yet, kind of like a little bit undercover network anonymity meetup tomorrow. Networking anonymity meetup. So this is specifically if you're interested in that. I think it's on the Luma, but I don't know if it's on the DevConnect calendar. I can send you a link. It's going to be a small, intimate event so far, I think.
And if you need money to book the return flight, there is ETH Global Hackathon. 3 days hacking.
If you want to get home, get a win the hackathon.
People want to stay in this beautiful country.
Awesome. Thank you so much again, guys. Really appreciate it. Yeah, awesome. So that was the very end of the EPF6, the very end of the panel. Trent, want to say something?
Yeah, I just want to say thank you to you both. So I was involved with the very first CDAP, which was many years ago at this point. And you have both taken that, and every year it seems like you you are able to produce a better program. And just listening to the talks is incredible. So massive, massive kudos to you both, Mario and Josh, and excited for the next cohort. And you've just done an incredible job. So thank you for your work here, both of you.
Yeah, thank you, Trent. Yeah. Okay. Lovely. Thank you, Trent. Thank you, everyone, again. And yeah, thanks for the wonderful presentations by Follow. Thanks for the panel. Many strong thoughts to take us to home with us, right? And now we are free. Finally, it's over, guys. You are free. There is a dinner in an hour, 7 p.m. in Raggio Osteria. It's Italian place. We have a bunch of vegetarians. We couldn't book a pariscia, so we have an Italian place. So we have options for everyone. So you're all invited. Please, if you can, please join us for a dinner at 7. We'll share the links and everything, of course. So please take some time to chat and chill before we get there. But I'll see you at dinner, everyone. Yeah. Thank you so much again. Cheers.